Alright, welcome everybody to day 3 of IS 50A. We're going to be continuing our exploration of Unreal Engine today. And usually during the first week I talk about principles of game design, but I often do so by playing like real life board games, so I'm probably going to put that off till next week. We'll just start going on the programming immediately. I don't think you guys are going to mind too much. So go ahead and launch Unreal Engine 5.02. Or if you're watching this in the future, whatever the latest version is, they update all the time. So today we're going to go over more on lighting. We did a little bit with it last time with the point lights. We're going to go a little bit more into lighting today. And we are going to do more programming, more ways of triggering events, and then learning more things you can do with events. So when things happen, yesterday we learned you could play a sound and you print something to the screen, all well and good, but there's a lot of things you can do. Video games are pretty wide open in terms of options. So we'll go over some more stuff today. So where's my summer 2022? There we go. And I've actually got a little PowerPoint presentation I can show you on the topic. We're going to talk about lighting today. Yep. And one asset up, that's fine. New plugins are available, that's fine. So we got this misty. I liked your misty morning villages. Is really cool. Maybe we'll go through those today. So you can see that lighting adds a lot to a scene, right? Lighting and fog are really important to set the mood of a map or a level or whatever you want to call it. Humanity has for millennia associated warm fires, sitting around the fire with your family, with safety and comfort and peace and things like that. That's why, like in very depressing video games like Dark Souls, you rest at a bonfire, right? Like it's not a coincidence, I don't think. And you can see that you can create really interesting things, and there's more you can do with lighting as well. For example, lighting is often used to indicate things of interest, and we'll get into that. So here we have a little thing on lighting. Now, in video games, like I said, in game development, one of the hardest things is just learning the lingo, the vocab, the jargon. Okay, and one word that you will hear a lot when making video games is the word normal. Ada, do you know what it means to be normal?
No one is normal. Honestly.
Ada says no one is normal. Okay. Well, that's
Everyone
not...
is unique, so
Everyone's
I'm just gonna say that.
Yeah, it's fair. It's fair. Thomas Kincaid references. Yeah. For those of you that don't know Thomas Kincaid, he was a painter of light who did pastoral village scenes mostly. There's usually a house with warm, glowing lights and a floodplain. That's the thing that always gets me as a homeowner, is that like all of these houses are gonna flood. Like, like look at that. Like, yeah, okay, fair. That one's fine. But just you get one heavy rainstorm and there's water coming right in through your kitchen. Like, I'm sorry. Like, this is
Actually, that was a little elevated.
This one's a little elevated, but this is on an ocean. You're gonna get a storm surge, and that's gonna toss waves in through your chimney. Okay, I'm sorry.
Maybe it's just like an even galleon and the house goes underneath the floor.
Yeah, that one's a little more elevated. This is a little more acceptable. Anyway, my own personal rant about Thomas Kincaid is they always put the houses right at the level of the stream, and I'm just like, no, don't do that. That's a really bad idea. You want to be up. Okay, so normal, right? Normal. So there are 2 different meanings in game development, other than, well, 3 if we count my daughter's, people are normal kind of thing. There's 2 different meanings in game development of what it means to be normal. Okay, so the first is length 1. So if you say you have normalized a vector, you have made the vector of length 1. Okay, So 1 centimeter long if you're using Unreal Engine, right? And that's useful in a lot of circumstances. If all you want is direction, then typically you will normalize the vector in the direction you're moving. So like if you have a car, you're making Cyberpunk 2077, your car is driving down the street. Typically, the anytime you do anything with the direction of the car, like if you want to see, hey, am I about to get run over by the car? Typically, the direction vector of the car is going to be normalized, which means it is shrunk to be 1 inch long, pointing in the direction of the pedestrian or whatever it is you're worried about running over. And the reason why we do that is because it makes the math easy. Okay, if you work with normalized vectors, 1 centimeter in this direction, 1 centimeter in this direction, there's some math operations that you can learn that say, hey, are they pointed the same way? Are they pointed at 90 degrees to each other? What's the deal? And that's very useful in video games. And we'll have a whole lecture on that. But if you want to backstab somebody, right, in a video game, they have to be looking the same way that you are. Okay? And so in order to do that, you normalize the direction they're looking, you normalize your look vector, and you do this math operation that I'll tell you about later. It's called dot product. And if it's, mostly in the same direction, then you're like, boom, double damage. Okay? That's normalizing a vector. Normalizing a vector, or a normalized vector, is a vector of 1 unit long, 1 centimeter long. Okay? You guys understand that? And that happens all over the place. Most of the time when you're working with vectors, you will see them being normalized. So everything has a unit length. You don't want to have a vector with a length of 0, for example. Various things will explode if that happens. Okay. Just trust me on that. The math is a lot easier when everything has a length of 1. Right. So, things like that, like if you're going to use a vending machine, you want to make sure that you're looking at the vending machine. Normalized vectors are used for all that kind of stuff. So, then a normal vector, though, is not the same thing as a normalized vector. Just because. And so a completely normal mathematician can normalize a vector to get the normal vector. Okay. So a normal vector is a vector pointing out of the plane at a 90-degree angle. That makes sense? So if you have your table and you put your pencil straight up on the table, that is a normal vector. Okay? It is a vector pointing out from a surface at a 90-degree angle perpendicular to the surface. Okay? And this is used all the time as well. For example, if you throw a ball at a wall and it hits the wall, it will reflect around the normal vector. Okay? So if you... let's try this real fast. So if you have a wall, the normal vector is pointing straight out from it, like that. And so if a ball comes in and hits the wall, it will reflect around the normal vector, if that makes sense. Okay? So if it was traveling at 5 units to the right and 2 units down, now it's traveling at -5, in other words, 5 to the left and 2 down, right? So it reflects around the normal vector. And then the top of the wall, the normal vector is here. The bottom of the wall, the normal vector is there. And the right side of the wall, the normal vector is there. Does that make sense? So the normal vector is used in lighting. Topic for today. How does light bounce off a surface? Well, it reflects around the normal vector. Okay. You guys with me on this? Am I exploding any brains? And does this make sense to you? Okay. So hold up your hand and show me the normal vector of your hand. Hold your hand up. Hold your hand up like you're about to accept a payment or something like that. Yo, pay me. Put it on the screen. Put it on the screen. Like flat. There you go. And then show me with this pen. Don't stab yourself with it, girl. Jeez. Okay, yeah. Use the blunt end into your hand. Okay, all right.
All your students can see it already
Rest
my
of the
little
channel.
hand.
Okay.
Which is funny.
Okay. So yeah, normal vector now. Good. Okay. Now move your hand around, and rotate your hand on screen. On screen, you're coming off the video screen. Like rotate it sideways, things like that. Do you see how the normal vector kind of moves no matter which way she rotates her hand? The normal vector is always pointed.
Not really.
Right when I'm saying that, she drops the normal vector. There is no normal vector now.
There is no normal vector.
Yeah, don't wiggle the normal vector. As you move your hand around, the normal vector is always pointing
I
out.
think I expect humans to move during an earthquake.
The normal vector just sticks with your hand.
I think I expect humans to move during an earthquake.
All right, hold your hand down like this,
Yes.
and then show me where the normal vector is. No, that's out of the palm. Out of the palm. Don't stab yourself. Okay. Okay. Now hold it out so they can see it. They can't quite see it. I don't think. It's no over here. There you go. All right. Thank you, demonstration person. All right, give me that pen back.
That drops the pen a bunch of times.
Don't stab yourself. Come on. Okay. So yeah.
Don't stab myself for fun.
All right. So that is a normalized vector, and oftentimes the normal vector is normalized. But these are completely two different concepts. One is a unit vector, a vector of 1 centimeter in length. The other is a vector pointing out of a circle. Okay. Sims, did you have a question? I see you've started typing a couple times. It's like when a student kind of puts their hand up in class and puts their hand back down. That's the Discord equivalent.
He knows.
No. I don't care about that. Don't care about that for now. It's all about the basis. Just gonna ask if it was like line of sight. If you wanted to do line of sight, no, I don't think so. Yeah, line of sight. We'll get into how to do that actually as well. Like, normally. It's all mathy stuff, don't care. Okay, here. So what I want to talk about today. So lighting. So how much light does your hand get? Let's say that you've got a light source. Ada, do you have a cell phone or something? You turn the light on right there. Turn the light on it. So we got a surface here in a video game. And no, use the cell phone. You turn on the flashlight.
You said
Okay.
turn it on, so I do not know what it is.
So I've got a surface here, and I want to compute how much light is hitting the surface. Okay. Now you can see I'm already getting some light from
I'm not turning it on.
from around, right? And so the light that I'm just getting kind of from around is called ambient lighting.
Okay, there we go.
Okay. It's called ambient lighting. And so a lot of times when you're in a real life situation, there's just ambient lighting. You see there's lighting on the carpet and on, just around. And that's because when it's a sunny day, light will just kind of bounce around. And as long as you're not in like a perfectly blacked out room, like light will just kind of be around. That's called ambient lighting. Now we have a point light here. And you can see that when my hand is facing the point light, it's fully lit. Like it's collecting a lot of light. The closer I am to the light, you see how it's like exploding out of the camera. When I get further away, it gets a little bit dimmer. Right? But watch this. As I rotate my hand stops getting lit by it. Right? So the more the normal vector is pointing at the light, the more light I get. And when the normal vector is pointed at a 90-degree angle to the light, it doesn't pick up any of it. Thank you, Ada. That makes sense? So there's two things that kind of control how much... I'm now blind. There's two things that control how much light you get from a light. One is how close you are to it, and the other is if your normal vector is pointed at it, you get 100% of the light, and as you start not being pointed at it, you get less and less light until you get none. And that's a trigonometric function, right? It's the cosine, right? So if you're pointed right at it, the degrees are 0, and as you start pointing away from it, the degrees drop. When you're at a 90-degree angle, the cosine of 90 degrees is 0, right? So when your surface is pointed at an exactly 90-degree angle, all the light passes right by, you get no lighting from it. Okay, so that's the upshot of lighting. Now, not all kinds of lights are like the sun. Like the sun is called a directional light. Okay, and the reason why it's called a directional light is because all the light rays coming in from the sun are at the same angle. The sun is 1 AU away from the Earth. Ada, do you know what an AU stands for? It's a big unit of measurement.
Something.
It's an astronomical unit. It's how far the Earth is away from the sun. It's 1 AU by definition. So we're so far away from the sun that even though the sun's radiating light in all directions, right? By the time it gets here, all the light rays are basically all traveling in the same direction, and so it's called a directional light. And so, if you have a mountain or something like that, the mountain facing the sun is going to be lit, the backside is going to be in shadows, right? And we've played with a directional light before. You can rotate it and change, the shadows and things like that, and that's actually really important for setting mood as well in your video game. You have to think about the time of day it is, because it's definitely got a different feel to it when you're at twilight, when you're at sunset, when you're at noon. Okay. You also rarely want. You have a question?
But isn't there a video in Unreal Engine about how to how to choose one specific time of day? You can just do this cycle of day
You can.
two,
You absolutely can. And a lot of times when you're doing an RPG, you'll do a day-night cycle, right?
Mm-hmm.
And they'll cycle between day and night. A lot of times, though, we don't bother with that because we sort of want to craft an experience, right? Like if you're playing Persona 2, or Persona 5, and you go to the beach, it's going to be in the daytime, right? Like if you sit there on the dialogue screen for a while, like because you're going to go make a sandwich, you come back and it's now nighttime, and everyone's like still sunbathing on the sand. You're like,
what the heck?
what the heck? This doesn't make any sense. So a lot of games.
Actually, that kind of makes sense if it's cool at night and the stand's still hot.
Yeah, but you can't sunbathe when there's no sun. So.
Okay, not sunbathing. It's called sandbathing.
So if you wanted to add day-night cycles, in a lot of games, it takes way too much time because you have to build in AI, going home, going to sleep. It's a lot of work, and so a lot of games when they're crafting a level, it's just like this is the time of day, and the time of day, sandbathing, yeah. The time of day that you pick controls the mood a lot. So, games are really about creating an emotional experience for people. And it's not necessarily true for games like chess or backgammon, where it's just like a pure puzzle game. But if you're talking about even something like Mario Brothers that doesn't have very much of a plot, Princess Peach has been kidnapped for the 90th time.
I don't know. Okay, Bowser, just get your own girlfriend, okay?
Thank you. Even then, the different levels of Mario worlds will have different themes, right? So you'll inevitably go to a sand world, and the lighting is very different from when you're in the poison world or whatever. Right? Okay. So yeah, there's 4 different kinds of lighting we typically work with. First is ambient, or sometimes called global lighting. And when you have ambient lighting, there's just light kind of around. And that actually simulates situations on Earth where, in most cases, during the day, at least, there's just kind of light. If you just stare at the corner of your room, there's not any light shining on it particularly. But there's just light kind of bouncing around. And especially when you have a little bit of haze in the air, the light will reflect off the haze and just kind of give a nice, warm, kind of feel. Now, if you disable ambient lighting, that's kind of wild. And it feels like a very different game if you turn off ambient lighting. If the only lighting you have is direct lighting, you have a spotlight shining on a wall, and then everything else is black, that's a different game that you're playing. For example, Doom 3 did that. And
does it look like trash?
Does it look like trash? I don't know.
Actually, no, it doesn't look that much like trash.
And so basically, in Doom 3, the only... Forbidden? Really? Okay.
What the heck?
Yeah.
forbidden to look at this picture even though you can see
Even though it's right here, yeah.
there.
Yeah, you can see there are some lights and they light the zone, but like everything else is like just black, right? Like you got some emissive lighting here. So emissive lighting are things like things on the walls that actually glow, like like a console screen, things like that are emissive. Okay, so you got some emissive textures here, but everything else is just pitch black, and it's a weird feeling. It's very like it was a major criticism of Doom 3. It was a deliberate decision. Like it wasn't an accident. It's a deliberate decision, but it was a major criticism of Doom 3, which is that it was so dark you couldn't see anything, right? And they did it that way because monsters would come out of the dark and scare you. That was the point. Like you walk around and there's a monster. You're like, no, it's scary. And so you have a flashlight, but you can't have your flashlight out and your gun at the same time. It's literally impossible for any person to have flashlight/gun technology. So
I mean, just like take duct tape and like put like your flashlight on top of your gun, just like duct tape.
Yeah, that was actually the number one Doom 3 mod. Was exactly what my daughter described. You could be a modder girl. Was they took the flashlight and duct taped it to the gun because that's what they do in real life, right? Like or they walk around just like this with a flashlight and a gun together.
I mean, I don't blame them if you can't if you have a 50 caliber in one hand and a flashlight in the other. I don't blame them to say you can't have a flashlight at the same time.
Yeah, no, 50 cal you're not one-handing. But you see how this looks with no ambient light? Like it's just a very harsh environment. It means there's no particulate matter in the air. And now, it's on Mars. So, I mean, fair enough. But Mars always kind of looked dusty to me. Like, I don't know. Like, I think there'd be...
Fresno.
It looks like Fresno. Good job, girl. Right? But you guys see the lighting here? Like, this creates a very different experience when there's no ambient lighting. Like, it's just black. You see this is just black. You can't see anything.
Well, at the same time, I actually do kind of have like the point that where you have to have like your flashlight look around. But I feel like it would be like better if it was like multiplayer because one person can be like holding a flashlight and the other people holding a gun.
That's true. Yeah. Like Katie said, a mounted flashlight. So they changed on the BFG edition. I only played the original version of Doom 3, and it was just. It was like I kind of like understood what they were doing. Like, okay, you need your flashlight, you need to see where the monsters are, then switch and shoot at them in the dark. And when you shoot, it flashes lights, and so you can kind of see, like, you can use your gun's, muzzle flash to see things. And it was really tense and things like that. But what irked me to the nth degree in this game was that it would teleport monsters in behind you. So you'd walk in, you'd clear a room, and as you're walking out, a monster would just appear behind you and stab you in the back.
Yeah, we were totally here.
And you're like,
seriously?
I literally just cleared this room. Like, and it would be fine if, like, you could see, but you can't see. And so, doing that once or twice as a jump scare or whatever is fine. But, like, if you clear a room, like, you're punishing players for behaving in an intelligent manner, right? So, you can teleport using demon magic. Just get good. So I had some serious issues with Doom 3 as a result of that. And a lot of it was just the lighting. Like literally the lack of ambient lighting was my only real criticism of the game. Because the jump scares, like the teleporting, wouldn't be a big deal if you could, just be like, there they are. You just get hit. Thanks. Okay. Other places where ambient lighting would be off would be like in a cave or something like that. If you're dark underground. Ada, do you remember when we went to Boyden Caverns?
Oh yeah, I love Boyden Caverns.
Yeah.
It's really fun. I reckon if you're going to go with the water path, you should probably bring like some waterproof shoes because you're going to be in like 2 feet deep water and be like navigating around it.
So this is in Sequoia, so it's not too far from us. And you like walk up this path, and there's a cave, and there's all sorts of cool cave formations.
Yeah, and there were people like banging their hands on like the stalactites.
And the reason I mention it is because at one point in the tour, they turn off all the lights in the cavern, and you get to see what natural cave lighting actually looks like, which is
actually lived in there.
Which is black. Like, we are not used to there actually being pitch black in real life. Even at nighttime, There's street lights. There's the moon. There's starlight. Various night lights and things like that. The cell phones charging, things like that. There's always a little bit of light, and the human eye actually works pretty well in low light situations. Like the human eye can detect individual photons. That's how sensitive the human eye is. Our eyes are far better than like any, for general purposes, any scientific or commercial camera out there, right? And when you're in a cave, it is black. Like the first time I went to it, I've been there I think 3 times. They turned off all the lights, and I'm just sitting there going like this. They're like, "Hey, try moving your hand in front of your face," and there's no sense of motion at all. Like normally, even when it's dark, like you can see like something moving in front of your head.
Like your silhouette.
Can't see anything. It is disorienting. And then they turn the light back on, and everyone's like this, like, yeah. You look like a moron. Yeah. People who go caving terrify me.
Actually,
like
no. It wasn't that bad because people were cheating and turning on the phone flashlight.
Yeah. So the first time I did that was before the advent of cell phones, right? And if I can put on my old man pants and be grumpy for a little bit, the first time I did, they turned it off. It was black, and it was a wild experience. I'm still talking about it in my lectures today. 20 years later. And then when I went with my daughter, was it 2 years ago or so? No, it was 2021. It was last year, I think.
It was not last year.
2021? Was it 2020?
It was like 2-3 years ago.
No, it was during the pandemic. Auntie A came out during the pandemic.
No. Auntie, no.
Yeah.
Auntie A did not come out. It was one of those times that Auntie A did come over, but not during the pandemic.
Yeah, it was during the pandemic.
Or like the early pandemic.
Yeah. So it would have been 2020.
It's like
okay.
really, really. So
Time is
definitely
weird.
not last year. I'm just gonna tell you that.
Yeah, 2020. Okay. So so they turn off all the lights, and then immediately all these tourists like turn their cell phones on, like, huh? And they're like, I'm like, bro. Like one person was taking photographs of the darkness, and I'm like,
no, mommy actually took a picture of the sun.
Why did you? I want to remember this. I need to take a picture of pitch black. Flashes are going off. I'm like, seriously.
I want to take a picture of the sun.
Cell phones ruin everything. No, I like cell phones, but
no, cell phones do not ruin anything.
Sometimes you just need to put your cell phone away and enjoy being absolutely blind. Okay.
Yes, that's very true. Very wise words.
Gotta turn up the brightness on my phone so I can see this picture in the dark. Yeah. What? Like they immediately did it. Like it was just their first reaction. It wasn't a surprise. Like they're like, we're gonna turn the lights off.
Take a picture of the dark.
Yeah, they're like, we're gonna turn the lights off so you can experience natural cave lighting. So they knew it was coming, and they still like shining it around. Okay. Anyway. So that's ambient lighting, and it's okay to turn off ambient lighting, but you need to know what you're doing because. If you're on the moon, if you're on Mars, if you're in a cave, it's one thing. In general, though, it's not a fun game experience to have a black screen. Right? Like, if you've ever played a video game where they blind you, like a flash grenade goes off, it's usually only for a couple seconds. If that was like for an hour, just nobody would play your game. You know what I mean? So, all right. So directional lighting is the sun. And then point light is what we put into the world yesterday. And a point light is, the icon in Unreal Engine is a flashlight, right? Or not a flashlight, a light bulb, sorry. Because the light just kind of goes out in all directions. Now, here's a question. With a light bulb, does the light go out in all directions? It's an open-ended question. If you have a light bulb, does it radiate light in all directions?
It does until it can't anymore. It goes as far that it does, but it goes as far as it can.
Okay. So, all right. So a lot of people have twigged to what I'm getting at. Yeah, it doesn't go through the base, right? So if you have a light bulb on your ceiling like I do, it doesn't go up very well. But also, let's just talk about the irradiated area above it. Is it equally lit as well when you have a light bulb? Have you ever had a light bulb with no lampshade on it or whatever?
No.
Turn it on, you look up. Is it an even glow or not?
Well, if it's too close to this, if it's too close to the ceiling, then like it's like concentrated on one point. So.
Okay. What does it look like, Tim Crom?
Just gonna point to the light bulb up there. I mean, that one's pretty bright, so I just have to say that one actually does light up the whole room. So.
Okay. Trademark. Sorry. What about Ethan? What does it look like if you have a lamp, you turn it on. There's no lampshade. You look up at the ceiling. What do you see? There are beams. It's streaky. According to Tim Crom, trademark. The filament in old school light bulbs isn't a point. It's a squiggly line. Also true. What about the CFDs? So there's incandescence, there's halogens, there's the compact fluorescent something CFD lights, and nowadays most people use LED lighting because it's more efficient and doesn't have mercury in it. Yeah, it doesn't cause a fire like halogen bulbs do. But I think all of them have the same issue, which is they don't actually send light evenly. How does 360-degree camera work? You have to have multiple cameras. I had a friend that did that for Google. You'd drive around with a bunch of cameras on the roof, and it just photographs in all directions. So lights are not even. Now in Unreal Engine, you'll notice that it is. Right? So it's perfectly smooth,
And
even,
the people are
in
gonna
360 degrees, right?
The people who are going to play your game are going to be like, where in the world is this light coming from? I see a light bulb.
Now every light has a temperature. Even if you have white light, you have warm, and you have blue light, and everything in between, right? And so adjusting the temperature of your white light is really important for setting mood as well. We associate yellower, warmer colors with safety and fire and family and things like that. Bluer light is associated with cleanliness, hygiene, doctors' offices.
Boring offices where you have to do too much paperwork.
Right, laundry room maybe.
Depressing areas,
yeah. And so I actually kind of like bluer lights.
Wait. I think your students are actually just typing in suggestions too.
Spaceships, offices, yeah. Mm-hmm. Exactly. And this is a very participatory class. Please don't just sit there and be quiet.
Stop being quiet.
Yeah,
When did a teacher say that to you that often?
Yeah, talk in class. So that's one of the main benefits of doing Discord, is that you're free to talk while I'm rambling on, and I like that.
Don't talk to each other. Talk to the teacher.
It gives the brain a sense of alertness when it's blue. Yeah. Whereas warm light is like, I'm gonna go to sleep sometimes, that kind of stuff. Yeah.
Roast marshmallow.
She's Alex when we're whispering, you can't see it. It's funny. You're currently screaming in my room. I can't hear you, dude. You're gonna have to scream louder. Okay.
Okay, I'll scream louder.
No. It's okay. Yes, thank you. Now, let's see if this is still an Unreal Engine 5. Let's see if it's in here somewhere. Where are you?
I mean, technically, it isn't a joke because if my dad allowed you to, you can unmute.
I don't see it in here right now.
Yeah, I think they're talking now.
Yeah, but in Unreal Engine 4 at least, you can load in the light profile from the International Lighting Society, I think it's called. And every light bulb that you buy actually has a profile on it that describes the function of what shape, what pattern of light the light bulb makes. And so as you look at the light bulb straight up to the right, things like that, the profile actually tells you how much of the light goes in each direction. And You could actually load them from the World's Association for Light Bulb Manufacturers and things like that, lighting manufacturers. You can actually put them into Unreal Engine, and then it creates a realistic looking light bulb. Pretty cool. It actually reads the, I think they're called ILS profiles, things like that. Let's see if it's, let's see if I'm remembering that right. Instrument landing system. I'm not seeing it over here, so we're not going to worry about it too much. Okay. But yeah, pretty cool. And they built support for like just the industry standard for describing lighting into Unreal Engine. Okay, so that's a point light. A point light, by default, just radiates light in all directions evenly. And you can mess with all sorts of things. Source radius, soft source radius. Let's see, cast shadows, direct lighting, volumetric scattering. So you can make it, volumetric scattering means it interacts with the fog more, right? So you have volumetric fog, so you can see the difference between this one and this one. Like the fog itself is picking up more of the light. So, pretty cool stuff. Pretty neat effects there. Oops, what did I do? Light color, attenuation radius adjusts. Do you see how there's that spherical outline there? So you can adjust the amount of world that the light affects. And yeah, and so the attenuation radius controls like where the light drops off, right? And so basically if you set it like this, the light just doesn't affect anything outside of the ball. Which you see how this one's casting a shadow down here. The light's spilling out of the doorway. Here it's not, right? And that's actually really important because there's maybe a performance impact on that. It depends if you have a dynamic light or a static light. But the more lights you have on a surface, the more math that has to be done for it, right? We talked about the normal vector and all that kind of stuff. And so lighting is actually one of the, more expensive things to do. You can slow your game down if you have too many lights, especially moving lights. Static lights, lights that don't move, can be baked. You can solve the problem, in advance. And then your video game doesn't need to figure out the lighting calculation every frame. If you have a static light that never moves and a static wall that never moves, you can tell exactly how much light's going to hit every point on that surface. And it saves it into something called a light map. And it writes down, okay, you get this much lighting, you get this much lighting, you get this much lighting, it's just saved. And then when you play the game, it just loads it. But if the lights move, it's got to do those calculations every frame in real time. And if you've got 50 lights and 50 moving boxes or whatever, it can drastically impact your frame rate. And so doing something like limiting the attenuation radius so that it doesn't affect all the boxes in the world is a good performance optimization you can make. Among Us. Okay. Let's see what else we got here. Inverse squared fall off. Interesting. Oh, what happened here? And do all sorts of things on how the light falls off. You sometimes want to mess with that if you're in a cylinder or something like that. The light doesn't. Normally, the light intensity goes down with the inverse square of the distance because it assumes it's a sphere going outwards. But if you're like in a long tunnel, the fall off behaves more linearly than because the light will reflect off the ceiling and floor instead of just going outwards. And so there's all sorts of options for messing with the lighting on that. Let's see. Here we go. Light function material. Maybe that's the one I'm thinking of. No. There he is. IES, not ILS. IES. Okay. So you can load. We don't have any assets loaded, but you can actually load a profile from the International ES. What's that stand for? Illuminating Engineering Society. There you go. So you can go onto their website and download the profiles for every light bulb ever made, as far as I can tell. And then load them in, and it'll look nice. Ray tracing. Yeah, it's good. Just play with them, to get the effects you like. Color's a big one. Lighting temperature is a big one, and then the attenuation radius, and then the candles. Where are the candles? Here we go. And so the candles, that's kind of the main thing actually right there. That's how many candles of light it produces. It doesn't sound to me like a metric unit. It's 16 candles and 12 bushels and 2 hogsheads and a butt. A butt is a standard of
it's 63
measurement.
gallons.
A butt is 63 gallons. There you go. Okay. So intensity is like the big one, right? So you can have.
What about a barley wheat?
Yeah. So a candle is a measurement of unit of light. So there you go. So okay. The international ES, yeah. So intensity is the big one, and then color and intensity and attenuation radius are the things I usually play with. Okay. And the all this stuff again controls the mood. Like if you're going to do a disco nightclub, obviously the lighting situation is going to be different from a cozy mountain village or something like that. All right. So a spotlight and a point light and a directional light are the things you're going to use a lot. Every level usually has a directional light. Every level typically has ambient lighting of some sort. But what you put into the world are point lights and spotlights. And so a spotlight, obviously theater, right? You have a spotlight shining on stage. But even things like an overhead lamp that has like a lampshade on it are typically represented with spotlights because the lampshade on the spotlight blocks upwards light. And spotlights typically have 2 different cones inside of them, an inner cone and an outer cone. The inner cone is brighter, the outer cone is dimmer, and then outside of that there's no light whatsoever. And we use spotlights for 2 purposes. One, like you just have a light, and if especially in like an interrogation cell or something like that, like we have ways of making you talk, and you shine a light in somebody's face. But besides just like putting in a light that behaves like a spotlight, the other way we use spotlights is to draw attention to things. And one of the biggest issues I have with modern video games is that they grab you by the nose and pull so hard because they're so afraid you're going to get lost, that you're going to get mystified, that you can't figure out what's going on, that they'll put a giant glowing yellow arrow. Here's the quest item. Come over here and pick it up. There's a map marker on the screen. They give you a quest. Like, I've lost my ring. Could you find it for me? Sure. And there's this thing, and it's like, and I go, okay, well, why didn't you look at the giant yellow arrow, dude? Just look at the giant arrow. If you lose anything, look at the giant arrow. And so it's just, it doesn't feel fun, right? It doesn't feel fun whatsoever when you're given a quest to do something, and they're like, oh man, I can't find my daughter, she's gone off, and then you accept the quest and there's a mini map marker for it.
Unless the mini map marker is it's really hard and there's like mountains surrounding it and it's a map marker, but like there's only one way to get there, and that one way is like loaded with ambushers and stuff.
Mm-hmm. Yeah, no, and I know what you're saying, Skyward.
Or they should have probably said something like, "Oh, the orcs have taken them over to the den." I heard it somewhere in the mountains.
Yeah, and the trouble is, a lot of times you get a quest, you just have no idea where to go. Search around for a barrel. And you're like, I don't know, man. There's a. Can you find this person? There's a range of like no help to like way too much help, and a lot of video games actually have options to turn off the help, But for me, let me show you a little trick that you can do. So let's say that the players in this game have to find a glass sculpture. So I can come over into props and see if I can find. There we go. This glass sculpture. That's right there. Okay. So good luck finding that. You know what I mean? Like. Right? All right, your quest, find the glass sculpture. You're like walking around, you're like, I don't see anything. And the game developer is like, it's right there. Why didn't you? Oh, that doesn't look like glass to me.
Looks more like a liquid metal or something.
And yeah, it looks like metal. It doesn't look like a glass sculpture. Yeah, I don't know. But like, people will just like run right past your quest, and game developers. That's why they put those yellow arrows on it, because they're just like, it's right there. It's right there. Why do you not see it?
Yeah.
But if you do that, if you give too much help, then people are like, that's not fun at all. Because the fun of a search quest is the searching. It's like playing hide and seek. Hide and seek's fun, right, Ada? But if everybody just told you where they are, right, Ada? If you're playing hide and seek and everyone's like, I'm in the closet, then it wouldn't be fun, right?
Yeah.
And
I'm in the closet.
And one of the things that we talk about in this game is like what makes things fun. And it's not fun to just ruin the entire game, of hide and seek. It's also not fun to not find it, and so you have to calibrate very carefully for people of all different skill levels, and some people have poor vision, and things like that as well. So let me show you a little trick. So if we put a spotlight on this, this is a little bit obvious, right? This is on the too much help side.
What?
Can you find the statue? It's like, thank you, game developer.
I can see it.
Thanks. Like, and players get annoyed at you, when you do that. But if we turn the light down.
But what if it's like a maze and it's like this very tucked away corner? Then you might want a little bit of light.
Yeah. And so with just a little bit of lighting on it, it highlights it. You guys see the difference there?
Yeah.
And so before, the thing just kind of faded into the background, but the human eye is drawn to light. Okay? Our attention is drawn to shiny things and to lights and things like that. And that's why spotlights are used in the theater. They're used in the theater to tell us who we should be paying attention to. And so if you put a spotlight, and it's not quite lined up, is it? If you put a spotlight on an object, then that tells our brain very subtly, especially if you turn the lighting down. I could probably turn it down a little bit more even than that. Put half a candle. So this is 16 times lighter, less light than the starting one. And there you go, right? Like, it's just a very subtle highlighting, and I could probably even turn it down more. I'll put a quarter candle. With just a little spotlight. Then as the person's running around, they're like, I don't see the stupid statue. Where is it? Oh, there it is. And you turn it down enough that it's not like yank, I'm getting yanked by my nose. But you're like, oh, look, I found it, Then you walk over and whoop. And in fact, I would say that anytime you have anything that you want your players to see and to pay attention to, you need to put a spotlight on it. With very few exceptions. Like if you're doing a video game where you're like a police and you're investigating somebody's desk, and like there's a golden bell. Why do I have a golden bell? Ada, why do I have a golden bell on my desk? Okay. It's a clue, right? I have no idea what this is.
And it's way too loud.
Here, take it away.
That is way too loud.
Have a button that spawns an arrow pointing to the objective. Yeah. Or Batman, any of the Batman Arkham games, you enter detective view, glowing green Riddler trophies in the Arkham series. Yeah, exactly. I don't like collect all these random objects quests. Yeah. But like, if it's like if the game is like investigate somebody's desk, right? Like you're police, there's a crime scene, and there's just like 50 things, right? If you want to highlight the fact like that bell is important, like the bell murderer was here, or whatever, toss a really light, spotlight on it, and even this, like I could probably even turn it down to like an eighth of a candle, right? So this is 64 times less light than the basic one, and it's still, oh, there it is. And see, I turned it down that much so that you can't see that the game designer put a spotlight on it. Because when you do this, like when it's too bright, like it's not fun. Okay, there it is. Yeah, thanks. It's not fun when you do that. And so, like I said, usually it needs to be, just even just a little bit of lighting like that is enough that it just pops. Oh, there it is. It pops off the background, right? And so you'll see this in video games. Like you're in some Mass Effect style science lab, and there's a sus beaker or something like that. Put a little light spotlight on it so that it stands out from all the other beakers. And you walk over there, and the green, press E to pick it up, shows up. You're like, oh, look, I found it. And if you don't do that, then the person sits there and stares at each item on the desk, waiting for the little interact icon to pop up. So, Mario Odyssey, where there's just things everywhere. Yeah, that works also. But do you guys see this? Like, I've turned this thing down 64 times from the original spotlight value. And you see there's a little sheen on it. There's a little glow on it. You can't even see the spotlight anymore, right? But there's just a little, it's a little shiny, a little reflective. So, Nancy Drew, yeah. But I mean, like I said, you'll see it everywhere. The, one of my only criticisms of Kingdom Come Deliverance is the spotlight too low on this? See, to me, here, you see how it's like kind of stands out a little bit? Watch what happens if I just turn the spotlight off instead. See that? It way blends into the background more, right? Even at 1/64th illumination, the spotlight is still enough that the thing stands out, and you can mess with it. Yeah, that's exactly right, Margaret. You want it low enough that you don't get the feeling the game developers are just trying to make the game easy for you, but you want it strong enough that it highlights the object. Gives it a nice luster. It's relying on ambient light. It blends them all. Yeah. Halo 3 ODST is a good game. Always make the player feel clever. Yes, exactly. It's like when you're teaching kids how to play, right? You want them to feel clever, right? If you beat them every time, they just sort of give up, right? And so when I started playing hide and seek with my daughter, I'd beat her every time. And you remember that girl? Mm-hmm. Like, she would search a room and not see me, and then I would sneak into a different room, and then sneak in. After she would search, I would sneak into the room she had just searched, and she would just give up, And so I'd have to do things like, like move a door or something like that, so that she would wait. I heard something, and she'd come over. I found you, things like that. So you have to kind of like make it a little.
Exactly, admitting your skills to make me feel like I'm winning, it doesn't exactly help.
Well, you're like in 5th grade now, so it doesn't matter. We're talking about like when you're 2. So, and also she did get better over time, so she can actually find me now. She's learned a lot of my tricks. Like, I'd hide behind doors and things like that. So she'd walk in and walk out.
I just creepily see an eye and like the wedge of a door.
Mm-hmm. Okay. It's only important if you figure it out yourself. Exactly.
What
so
happened?
So it's
What in the world happened?
It's a delicate art, because your players themselves, some of them are going to be like smart and some of them are going to be dumb, and that's why most major AAA game studios go with the giant glowing bouncing yellow arrow, because if you get stuck, it's not fun, right? And so another approach you can do is, like, if they don't find it in like 5 or 10 minutes, then you help them. I mean, that also annoys people too. Like, we're detecting you're struggling trying to find the thing.
Or like, oh yes, I think I know where it is. I'm just gonna be super clever and check over here. Yes, aha, I've got it. Arrow. Serious. And I would just be like, seriously, I already figured it out. And you're like, oh, it's an arrow right here.
Or you have an NPC that's walking with you that'll give helpful advice. Be sure to pull the lever twice.
I mean, we do have to look up help for a lot of times for like
do a barrel roll, yeah.
for Skyrim. Remember how like you're supposed to look at the back of the claw?
Oh yeah. You have to pick up the claw and rotate it around to find the icons on it. Yeah, that was too subtle for me. There's a claw that you use to open the crypt walls or whatever there are in the tombs, and the icons that you're supposed to rotate to are on the back side of the claw, and so you're supposed to inspect the claw and rotate it over to find it, and that was like, phew, I just brute forced it. I tried every possible combination of the icons. The claw. Yeah. Okay. All right. So yeah. So like I was saying, Kingdom Come Deliverance is one of my favoriteest games ever. It's probably my second favorite RPG after Fallout New Vegas. And there's a quest in it though, where a guard is like, "Hey, there's a holy man that used to live in a cave over there. Could you find his spoon?" And you go into the cave, and it's a dirt cave, and you're trying to find a wooden spoon in a dirt cave. The spoon is brown, the cave is brown. And there's no spotlight on it at all. I spent literally 15 minutes in a room the size of my room here, staring at, sweeping the crosshair over every pixel on the screen, waiting for the stupid, interact icon to show up, because I literally could not see it. I stared at every corner of the room, and it just blends in. Like, there is no spoon, exactly. Can't that man just get a new spoon? No, it was a holy artifact, kind of thing. So
what's so special about a holy spoon? Like,
it was the there was like a hermit, a holy hermit that lived in a cave.
What do you mean a holy hermit crab?
It's like an hermit crab, yeah. And I don't see any pictures of it, but yeah, I don't know what I'd show you. It's brown. Everything's brown, and to me, they needed like just a very, very, very light, because you want it to be a little bit of challenge. Yeah,
it's like a birch wood.
Very light thing on it.
I mean, it's like a birch wood, so it's like a white wood spoon. I mean, if it's holy, if I was decorating it, I would probably make it like birch wood with like gold inlining.
Mm-hmm. So gold? No, he was a hermit. Like he was. It was just a wooden spoon, right?
He was a hermit crab.
He was a hermit. Yeah.
What's a hermit crab?
A hermit is somebody who lives on their own. So.
Hermit crab.
Find this. Yeah, this is exactly what it looks like. It just.
That's the spoon.
Who knows?
That's the.
This is literally what it looks like. You're just staring at this for like 15 minutes, like.
Let me see if there's a spoon.
There's not. It's just dirt. Okay. So. Yeah. So that's a spotlight. So again, spotlight used in two circumstances. One, you have a light that is a spotlight, and two, to draw attention to things. And basically anything that's important that you want to draw attention to, put a little bit of light on it. Anybody who's done theater, you know exactly what I'm talking about, right? So. The theater people understand this very much. Like lighting and like you can be a lighting major, right? And your college degree is in lighting and theater. Like it's there's actually a lot that goes into it. Okay, so nice. So surfaces themselves are usually not perfectly smooth, right? If you have a perfectly smooth surface, you're going to have a mirror, right? And so when you have not an occupation to take lightly.
Lame joke.
It was a dad joke, not a lame joke. All right. So.
Yeah, he's a dad yet.
I don't know. So the surface that is being reflected off of also, there's different properties on a surface, and in Unreal Engine, these things are called materials, and we're going to have a whole lecture on making materials, but today we're just talking about the lighting side of things. And so if something's perfectly smooth, you get what are called specular reflections. If you have a pool ball, that circle there is called a specular highlight, a speck highlight. And so you can tell that something is shiny and smooth by that specular highlight, right? You guys, you know what I'm talking about, right, Ada? It looks like it's, what material is that? Is that?
Plastic.
It looks like plastic, right? It's not metal. Metal would look different. It's not wood. Wood would look different. And it's a shiny plastic. It's not a soft or rough plastic.
I mean, it could be metal.
Okay. So when you have light coming in, a smooth surface is going to have a lot of specular reflection. Diffuse reflection is caused by irregularities in the surface, right? So if you have like a coarse plastic, the light comes in and then it scatters in every different direction. And so you've got your specular from the shiny bits, you got the diffuse from the rough bits, and then ambient lighting is whatever's not exposed to the main light here. Okay. So there's now a spoon. Nice.
There's
Found it.
Wait,
Right.
where is the spoon?
Right there. It's the word spoon.
I found the spoon.
Yeah, we'll put it up on the stream so that people can see it. There you go. There's the spoon. Okay. So, does this make sense to you guys? So, and most materials have like a combination of all three, right? Like most are going to be lit with some specular reflection, some diffuse, and some ambient. And the combination of these three is how lighting worked in the 1990s. This is the old way of doing lighting. Okay. And so you have the diffuse color, specular color. Specular power is how sharp the specular highlight is. The narrower it is, the smoother the surface. Yeah, this is what 3D graphics looked like when I was in college. Teapots, the open-shield teapot is famous. And so you can see you've got, a specular reflection here, and the whole thing just kind of looks like garbage. Okay. Specular power, higher specular power, higher specular power. You see how this one looks shinier, right, than this one? This one looks like a coarse plastic. This one looks like a shiny plastic. So the new way of doing materials is PBR, right? So we all know PBR from the rodeo, right? Non-alcoholic. I had to put this on here because we have a dry campus and we've got college sophomores in this class, or high school sophomores in this class. So we're talking about non-alcoholic PBR here.
Well, doesn't it say beer right under
It's non-alcoholic beer, Ada.
That doesn't make any sense because beer is like...
Shh, don't question me. So PBR stands for physically based rendering. And so I don't even know why you drink regular PBR, let alone non-alcoholic PBR. Like, it just seems like a really bad idea. It's like,
how is beer non-alcoholic?
It's non-alcoholic beer. If you like the taste of PBR but don't want to get drunk,
Just
then
get PBR flavored beer. PBR flavored.
No, I'm not shutting her up, Tim. I was being humorous. Okay. It's diet soda. Yeah, it's beer flavored soda. How about that, huh? With all the taste of PBR beer. You know you've made some pretty poor life decisions when you buy the non-alcoholic PBR.
What?
You've reached a point in your life where you should just be reconsidering everything. All of the decisions you made in your life up to this point need to be recalculated and re-examined. Okay. So anyhow, PBR stands for physically based rendering. Okay. And so in PBR materials, you have things like the base color, how metallic it is, if it has clear coat, which like on a car is like 2 different layers. It's got a lot of different things. It's got emissive. Emissive means that it glows. We talked a little bit about that before. And we're gonna do a whole lecture on PBR in the bits. I'm just gonna stop with the discard that with the lighting thing here and come over here. Okay. So we got our point lights.
Yeah.
We got our spotlights. A rectangular light is like a window. Like if you have a window, or something like that.
That's what Thomas Kincaid uses when he tries to make art in a computer.
Mm-hmm. So light color. Let's see. Do we have? Where's the temperature? There it is. So if I were to put a window on this, no, whatever. If I was going to put a window on this house, then even though simulated, you see how it looks like, that's the wrong temperature. Let's see, 6500. How is that? Did I color it? Yeah, I colored it. Okay. 255, 184, 138. 134 was it? 255, 184, 138. There. And so you can have like windows. Windows are typically done using rectangular lights like that. So you can see, like if I just painted a little window on there, it'll look like light was coming out through the window, even though it's not. It's a separate light.
Well, you actually should put a light. Wait. Okay, never mind.
Yeah, light emitted from a TV, a monitor, anything that has like a square surface emitting light. It's similar to a spotlight, but a spotlight is a point that radiates out like that, and that looks weird when you have like a window, right? Because the window has light coming in a broad area. It makes the lights look a little weird. So yeah, doing a rectangular light. I think this is actually need to be put back a little bit there. There we go. Yeah, nice. Okay, that is lecture 1 on lighting. Now, like I promised, we're going to be talking about doing more things with programming as well. So last time we talked about pull my notes from last time. We talked about some events: mouse clicks, key presses, collision, overlap. We didn't talk too much about what kinds of things we can do, and there's also a couple other events, right? There's a lot of events, and you can actually make your own, right? So you can actually make a custom event, which is kind of cool. Make a custom event, and then any other part of the code can just trigger the event. Like you can make an event called like I've been kicked, and then when the player comes up and hits a button or whatever that kicks it, then it triggers the I've been kicked event on it or something like that. So you can make your own events, and then you can send that event to the thing. Oops. Fix my M there. Another one that's really important is event tick, which means every frame do something. Basically. And this is, we need to use that sometimes, but it can be expensive, right? One of the main benefits of doing event-driven programming is that it doesn't cost you any code, any running time. Like your code doesn't cost you any running time, right? Your code for a collision doesn't run except when it runs into something, right? And so it's not constantly running all of this code that you've written. It just sits there, it doesn't do anything until the user clicks the mouse. And once the user clicks the mouse, then something happens. When the user hits jump or space key, it jumps, right? It doesn't constantly, eat up cycles every frame. Event tick says every frame run this code, and so that can really slow down your game. If every frame you have a sentry gun that is checking to see if all the players in the world it can see, right? So like if you're in an MMO and there's 1,000 people in the game and you got one sentry gun and it's trying to see if all 1,000 people logged in on the server, it can see every frame. Oh Lord, and they might not even be in the same dungeon, right? Just trying to see if can I see him? Can I see him? It's the kind of thing you want to avoid if you can, because it is expensive. Sometimes you have to do it, but there's usually better ways of doing event tick. Okay. All right. So let's do on touch next. So let's make it so that when let's make a little barrel or something. Let's put a little cylinder here. And let's make an exploding barrel. That's always fun, right?
Are we talking about Donkey Kong now?
We're talking about every video game in the world. So if you see a barrel, it's red, it's going to explode.
or if it has, and you know it is explodable if it has the Jolly Roger painted on it.
Yeah, or a biohazard symbol. I don't know why biohazard barrels explode. It seems like a really bad engineering decision to make the things holding your most toxic substances explode, but there you go. So let's see if we got any useful materials.
Do those materials start with the? Do you get those?
Starter content starts with it, but I don't have anything that really looks like it. I'll do this one.
Biohazard. No, just do that one, the gold one.
The gold one?
The gold one.
How about that? That looks
It looks like the game's bugged.
It looks like it's bugged?
Yeah.
Okay. I don't really. How about this one?
Momentarily fading.
How about that? That kind of looks cool.
Do the gold one.
But gold doesn't explode. It's gold.
Gold dense.
Like, that's probably the best. I can.
Does titanium explode?
No. If your titanium's exploding, there's something wrong going on. Yeah, I'll go with that as my barrel. Okay.
If titanium explodes.
So everybody, please make a barrel on the little jump pad here. And what we're going to do is, when the player jumps up and touches it, it will explode. Okay, that's what we're going to do. So you can see it's kind of glowing. I'll accept it. That's an exploding barrel, sure. Okay.
Good enough.
Barrels of methane, sure.
How about steel? Would steel explode? Steel explode?
No, it shouldn't. Well, I mean, maybe it's holding something. Okay. Now, this is something that's really important. So once you got your cylinder in the world, let me know, because then I want everybody to be paying attention when I talk about this next part. Give me a thumbs up on chat once you've got your cylinder in place, ready to be exploded.
They call this rusty metal.
Yeah. So what we're going to do is we're going to jump up, and when we touch it, it's going to explode. Ada, you get your barrel in?
Yeah.
Okay. So now we're gonna. Right now it's just a cylinder, okay? And what's important is that it's a static cylinder. So if you see on the details panel on the right-hand side here, there's 3 options for every object, and you have to understand this. This is actually really, really crucial. And if you don't understand it, you're gonna have a sad time trying to do game development. Unreal needs to know what objects are gonna move. Because if they're not gonna move, it can bake all the lighting and bake all the shadows and all that kind of stuff into the map. It can pre-calculate everything. And right now, your cylinder should be set to static, which means it's not going to move, it can't change, that's it, okay? And we don't want that because we want it to explode, right? So if it was static and it went away, then the shadows for it would just stay in the world, because the game would probably just throw an error at you if you tried deleting it. Okay, so you can see here under mobility, there's 3 options. There's static, there's stationary, and there's movable.
Static and stationary look the same.
Static and stationary are very close, except a stationary object could be deleted, right? So if you touch the barrel, it could spawn an emitter, like boom, and then it deletes itself. And so when you have a stationary object, the game engine will compute all the shadows for it being there and for it not being there. And then when you destroy the barrel, it just switches out the shadows one for the other. Okay? And if you tried writing your code to delete the static object, Unreal Engine will yell at you, and it might crash the game. Okay, it's really important to understand these three options. The third option is movable. So movable means the thing can actually move around, right? In which case, it's not going to try to pre-cache anything that it doesn't have to. So if you want your barrel to have physics and to roll around and things like that, then it needs to be marked as movable. If it's not, you're going to have a bad time. So stationary objects can't move, but they can be deleted. They can maybe change their texture and things like that. Like, as you shoot it, like maybe it turns red or something. That's fine for stationary, but it can't move. If you want the barrel to, fly around and things like that, like if we look at these boxes over here, you can see all of them are marked as movable, whereas the ramps are going to be marked as static, because the ramps don't move ever, right? The house, it's grouped up, so you can't really see anything. The walls, the floor, everything's static. And the reason for that is you want everything to be marked static that you can, right? Because then the game engine can optimize it. If everything is movable, the game engine can't optimize away any of that stuff, and your frame rate will suffer for it. So you really want everything static marked static, everything that's movable marked movable, and it's really important for you to tag those things properly. That's actually one of the most common mistakes I see students make, is they'll try making this barrel explode when it's static, and then they're like, why am I getting an error? You guys all with me on this? Hit it? Does that make sense? Static, stationary, movable?
So like stationary, yeah, I think yeah.
Okay. So every time and it's easy to forget, right? Because you just put something out. I forget it all the time too. Like you just toss something out. You're like, all right, I want to make this. I want to make a little box, and I'm going to turn on physics or whatever. There we go, and then we hit play, and come over here, and then did it? Oh, it switched it to movable automatically. Good job, Unreal Engine. Good job. Okay, so when I turned physics on, it turned on movable for me.
Ding.
Nice. Okay. So, yeah. But if you ever try moving in your code or something that's static, then UE5 will get mad at you. All right. So here we got this thing, and we're going to make it explodable. Okay. So we're going to click on the flowchart thing. So I click on the cylinder, I click on the flowchart, and this is going to convert it to a blueprint object. And again, I'm just going to give it a name down here. Actually, let's see. Let me scroll over to the bill folder. So I'm going to be in the bill folder. So I'm in the right place. Where, like I said, all the stuff that I make goes into the bill folder. And then once I start getting stuff in the bill folder, then I sort it into materials and meshes and things like that. Sounds. Okay, so I'm in the bill folder. I click on the cylinder. I click on the thing. Where's the thing? There's the thing. Okay. It used to be a giant blue button. And this will be called Exploding Barrel. Can't have spaces. Exploding Barrel. Okay. And now when you go into the viewport, you'll see this is a little more interesting than the box trigger, right? Last time the box trigger was just this wireframe box, right? Getting runtime errors on the sound blueprint thing again. If you try stopping a sound after you've already destroyed yourself or something like that, then it will cause an error. Okay. Again, viewport doesn't really matter. This is a little more interesting. And if you wanted to, you can actually add things to your barrel here. Maybe I'll show you that next. But for now, let's just hop back into the event graph. And we don't need the barrel to do anything on it. Begin play. And it won't overlap anything. And event tick we don't need either. One thing, the little event graph tab up here. And let me see if it has, it does not. Okay, so I just start off by deleting all the things in the event graph.
Which is?
And then you made your colored cylinder. Okay, so let's snap back over here. So you made your colored cylinder, and then you have to click on the little flowchart icon. Like I said, it used to be like a blue button that said add a blueprint, and that made sense. The flowchart thing doesn't really make sense. So you click on that, and then just give a name to your blueprint that you want to create. A blueprint is a code, essentially. It's visual code. And I called mine Exploding Barrel. And I did not just create a new blueprint class. I selected the barrel and I converted the barrel into a blueprint class so that it gets copied over correctly. You can actually start with an empty blueprint and then add things to it, but it's hard to see the relative scale of things when you do that. Like if you just started with an empty blueprint, like how big is this in the world, right? So I typically will toss something into the world and then convert that into a blueprint. Okay, so event graph, event tick, go away, and we're going to do event hit. So what we want is when the player runs into the barrel, we want the barrel to explode, and maybe damage the player, maybe do a particle effect, poison cloud. I don't know.
Make an explosion sound.
Explosion sound. Yeah, that's good.
Explosion sound and spawn a fire.
Yeah, that sounds good to me. But the first thing I always do is I check to see if it works, because if you don't have the right checkboxes checked in the right places, this event will not trigger at all. And I'm like 70% sure that this is actually not going to work. So first thing I always start off by doing is just print string. And so if the player touches the barrel, it's going to be like a barrel goes boom. Okay? And the reason why I do that instead of playing a sound is, of course, your sound could be turned down. There could be issues with the sound. Print string is just the safest way of just telling, did this thing fire? And if it doesn't fire, then we have to go and find the right checkbox check to make sure that it accepts hit events. How do I get there? It worked for me. How do I get there? I made and colored my cylinder. That's it. Says disabled. Did you just open up a new blueprint class? Control Z. So what I did was I created a new event called event hit, and then I dragged out of it the white line and said print string. And then compile and save. And let's just see if this works. And if anyone's having trouble, please screenshot or stream. Barrel goes boom. Okay, it worked. Cool. So my pessimism was unwarranted. There's been way too many times in Unreal where like I make this huge blueprint and then just like nothing happens. Nothing happens. You're like, okay, what's going on? Why there's nothing happening, You did not get your string displayed. Okay. So you have event hit and print string set up like this on your splitting barrel blueprint. So let's see if we can figure this out. Physics, constraints, collision, simulation generates hit events is what normally needs to be ticked. That's why I was saying I'm pretty sure it's not going to work. It's because interesting, because it's not moving itself. Okay. Well, collision. Where are the collision settings on this thing? It's usually somewhere in here. Let's go back into the blueprint and the viewport with this guy selected. Collision. See, it doesn't have that turned on. It did. If you put the pin on the tablet, it moves my mouse around. Constraints. Collision presets. Here we go. You might need to check simulation generates hit events on it, and it should be set to block all. It doesn't generate overlap events because you don't enter it. Can you step up on it? Yes, if your step size is big enough. discrete physics state, multi-body overlap, trace complex. Barrel goes boom. Okay. Can you screenshot what you have, Sims? Or stream what you have? I'll pause the recording and we can take a look at it. Okay, so yeah, this is how I start. Okay, Ada, you good?
Can we make it so that we can make it say different things every time we the barrel explodes?
Okay. Yeah, why not?
Can we do that?
I mean, you don't in a video game. You usually don't want to print messages like this because it looks really weird. But yeah, let's. Did you get it working?
I got it to work, by the way.
Oh, awesome.
Yeah.
Okay.
You can go ahead and mute me if you want to.
That's all right. Whatever. Okay. So we could do like a branch or something like that. If you hold down B and click, if you hold down B and click, it gives you a branch. And then you could like do a, like if you want just a quick coin flip or something like that. So let's flip a coin, random Boolean, bloop. And so there's a node called, and these things are called nodes, by the way. A node is the rectangular thing that you program with in blueprints. So there's a node called random Boolean, it flips a coin. Okay. And you can see the Booleans. Booleans are true-false values. They're either true or they're false. Nothing in between, nothing else. True or false. And so what I did was I have a random Boolean feeding into a branch. It flips a coin. If the coin comes up heads, it prints barrel goes boom. And obviously we would replace this with code that caused it to explode or whatever. And if it's false, if it comes up tails, then we say barrel no boom, and we'd probably replace it with code that would prevent it from being touched also in the future, right? So that it's a dud. You shoot it and nothing explodes. But as a good placeholder when doing development, just putting text in there is a great way of seeing how it works. And then we launch. Barrel no boom, barrel goes boom, no boom, goes boom. You can see it's flipping coins left and right. Okay. So that is how you do random coin flips. There's other random functions as well. There's random integer, random float, things like that. As well, integers are whole numbers. Positive and negative are 0. Floats are decimals, 0.1, 0.2, negative 0.1, that kind of stuff. Different between print string and print text. So there's two different types in Unreal. One is called string, one is called text. And they're not exactly compatible. So, they're different types. In general, you use print string. I don't use text that often. I can look it up for you though. But yeah, string is generally what you want because basically anything can be converted to a string. So like if you drag a Boolean to a string, it'll just convert from bool to string for you. And in fact, we can do that for both of them here, and you can see it'll print true or false or whatever. False, true, false, true, false, true. Okay, so now that we got that going, let's make an exploding barrel. So we had some ideas. We wanted fire, we wanted sound, anything else you guys can think of when a barrel explodes. Pain, yeah, damage to the player, sure. Okay, so let's start with sound because we know how to do that already, right? So play sound at location, actually. So this is not going to be last time we did play sound 2D, right? Because 2D sound just appears in your ears, right? Like if you're playing background music or something like that, it's just playing, right? It's just coming out of your speakers. This, though, is an embodied sound. It's in the world somewhere. It sounds really weird if the explosion just sort of takes place around you when you blow up a barrel on the other side of the warehouse. What you want to do is hear the sound in the world where it is. And the way the human ear and the human auditory processing system in the brain works is really interesting. One of the neat things about game development is you learn a lot about how the human brain works, human psychology, human physiology works from making games. It's actually really fascinating. So, exploded, no boom, yeah. So...
Mine actually says 3 things.
3 things? Oh, nice. Very cool, girl. You're going above and beyond.
No, you only have to have, 2 things connected, but you have to, disconnect the first thing, and it'll still say it.
Okay.
It's weird.
So, the way that the human ear works is when you hear a sound, your left ear and your right ear will both hear the sound, assuming normal circumstances, right? You don't have earplugs in. So. And sound is not instantaneous. Sound actually travels somewhat slowly, right? Like if you were on the 4th of July watching fireworks go off, you'd see a big firework, and then a second or 2 later you hear boom, right? Sound's actually not that fast. And it's actually slow enough that your brain can detect the difference in sound waves arriving just in the centimeter or so difference between your left ear and your right ear, right? If you draw a line from here to here, shoot, I'm mirrored, but if you draw a line from here to your left ear and here to your right ear, it's almost the same distance. It's maybe a centimeter or 2 different. So you're talking about a very, very small amount of time different between the sound arriving in your left ear and the sound arriving in your right ear, but your brain actually detects it. When your brain detects a sound, it actually sends the sound waves towards the center of your ear from both ears, and there's neurons in your brain that look for similar peaks, and if it detects the same sound from the left ear and the right ear, the location in the brain, whether it's to the left or to the right, tells your brain where that sound is relative to you. And so sound on the left hand side is going to have traveled further to the right than the same sound coming in from the right hand side, because it hit the left ear first, it's sent the signal over, it's going to cross over the median and hit the right hand side. By the time the right hand side comes in, the brain detects it's similar, it says, okay, that's a sound on the left side of your body, that's a sound on the right side of your body, that's right in the middle, that's in the middle. And you can't really tell the difference vertically because the amount of time it takes to reach the 2 ears is the same. But here's the thing, you can tell the difference between a sound behind you and a sound in front of you. That's what your ears are for. Your ears don't just collect sound like radar dishes or something, right? The sound waves actually transform as they pass through your ears. Your ears are somewhat permeable to sound, and so a sound coming from behind your ear actually will get mutated in a certain way that your brain will recognize, and your brain will say, oh, that's behind me. And that's really amazing, honestly. That you can tell the difference between, close your eyes and snap your fingers in front of your nose and behind your head, and you can actually hear when it's behind you and when it's in front of you, even though that should be impossible, right? And so your brain can actually figure out 3D spatial location with your eyes shut. You can actually hear it, right? And you can have your friend do it for you if you think that you're cheating because you know where it is, right? Because of your ear. Your ear actually mutates sounds coming from different directions. Pretty cool. Pretty cool stuff. So, why am I mentioning that? Because that's why we use place sound at location. Because then it'll be in the world. You'll hear a sound coming from somewhere in the world. And depending on the game engine, it might actually do the mutation for sounds behind you, as if it was going through your ear. That's how 3D spatial audio works. If you have headphones on, it'll actually mutate the sounds to sound like it had passed through your ear. And then your brain will interpret that as a sound behind you. It's mind-blowing. It really is.
What?
And so if you have the game engine, if it's programmed that way, if the game engine's programmed that way, and my game engine was, I didn't write it, my boss did, we had 3D positional audio in 1995, 1996, because we knew about that back then. And so if something's below you and above you, the wave, the sound wave gets mutated. It gets modified in different ways if it's above you and below you and behind you and so on and so forth. And so if you have headphones on, the game engine can actually make it sound like it came from behind you, even though it's just coming right out of your earphones, and then you'll hear it behind you. That's why it's really important to use place sound at location. Okay, so a little fun fact there. Okay, what's the point of the coin flip? Because it will always trigger if it flips every frame. Because it's going to blow up, right? It's going to blow up, and then the coin flip's done, right? So you flip a coin, it explodes. You flip a coin the other way, and it's a dud, and you disable the ability to explode. So, but you just start with the text. Okay, so we're going to play sound at location. Now, the sound we're going to play is explode. Okay, explosion it is. Okay, and
So we're gonna get rid of all this?
huh? You're flipping things? You don't have to. No, you don't have to get rid of them.
I'm just gonna make a new barrel.
You don't have to get rid of them. You don't have to make a new barrel either. You can detach them and just move them up to the top and just come back to it later if you want. Okay, so the main thing that we need to worry about here, and like you know how I said there's like attenuation settings, so you can make the explosion sound different when it goes at different distances and through walls and things like that. So just an exercise to show the random bool. Yeah, but also you would build on that, right? You'd build on it and make it only flip a coin once. Okay, so the main thing here that we care about is the location. So every object in the world, everybody please pay attention right now, this is really important. Every object in the world has a location and world coordinates. So somewhere in the world there is the world origin. Let's see if we can find where the world origin is. 0, 0, negative 50. The world origin's right around here, I think. 0, 0, 0. That's the world origin right here. That's the dinosaur. That's the origin of the world. Okay. I think that was bothering Portnoy yesterday. So that's the origin of the world right there. Because there's like this like velociraptor or something.
Someone's calling you.
Undoubtedly spam. Do it later. Okay. You're trying to delete the origin of the world. Okay. Tracking my computer in the trash. It's funny. Okay, so where were we? So we need to get the location of the sound. So if we're to compile this and play it right now, you're going to actually hear the explosion coming from the dinosaur, right? So this is a very common bug, by the way, and I actually recommend that you keep the origin of the world around, because a very common bug is you forget to hook something up to the location, and your explosions will come from the world origin. So if you do this,
Oh my gosh.
well, it's setting off a lot of explosions, right? So the sound's going to be coming from the world origin over there. Now, what we want, though, is the location of the barrel. Okay? And so here is a really, 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 really important thing, is how do you get your location? Okay. So, oh, you can't hear it. No. Whatever. So there were explosions, trust me. So what you can do is you can drag out this static mesh component here. If you switch over to the viewport, you can see that this thing here, you can drag it out like that into your blueprint. And if you want to get the location, you drag out and you say get world location. Okay. And then you hook that up into the location. So XYZ vectors are orange, okay. And so we basically can grab the world location of our barrel this way. This is something you're going to be doing a lot in this class. Because getting the location of things is something you do all the time in video games, right? If you want to know if two things are close to each other or whatever. The hit location also works. That's the difference between that is you're not going to be able to tell the difference. I should preface this by saying the hit location is the location where you touch the barrel. The location of the barrel is the center of the barrel. So either will work technically, but it's slightly more accurate to have it be the origin here, the origin of this. But hit location works fine. Hit normal is the normal vector. Yeah, and so this will tell you when you touch the barrel, the direction the surface of the barrel is pointing at the place you touched it. So like if you throw a ball at it and you want to reflect the ball around the hit normal, like if you're making a racquetball game or something, then when the racquetball hits the wall, there's an event hit that gets triggered, you grab the normal of the wall and you have the ball bounce around it or something like that. Or you just use the physics engine to do it for you. Yeah, that's what I'm saying. In video games, there's a lot of terminology and a lot of jargon, and if you don't know what it means, you're just like, hit normal. Of course it's a normal hit. What is it? I don't want an abnormal hit. I want a normal hit. Yeah. There's a lot of terminology, and I just kind of explain it as we go along. Okay. So if you want to bounce projectile off a huge object, you would want to use hit location for the sound. Yeah, like if you have a racquetball hitting a wall, you want the bloop sound to come from the spot that it hit. Sure. But for me, the barrel exploding should probably come from the center of the barrel. Like I said, you're not going to tell the difference because you're talking like a matter of like 5 or 6 centimeters on an explosion sound. Like you will not detect any difference in the code. But I kind of wanted to show you the get world location node because it's really important. And so you can get the world location of anything. You drag the thing over, get its location, look it up. And then when we play it, now the sound comes from the barrel, which I guess you can't hear, but whatever. Okay, that sounds
the same.
It really does. It's a loud explosion. It's hard to get, like, when explosions are really loud, you can't really tell where they're coming from. They just kind of overwhelm you.
Explosions.
Yeah, it's an explosion. Okay, so we've got our sound out. Next up, we want to spawn an emitter. So let's learn something new. So let's do spawn emitter at location. And and for this, it might make a little bit more of a difference that you're getting it from the origin of the barrel and not the hit location, because the explosion is going to be centered on the origin of the barrel this way, whereas it would be from the point you contacted. Might make a slight difference. Okay. And so this is a node called spawn emitter at location. And I'm just going to use the explosion particle effect. And yeah, that's fine to me. So the main thing is I'm doing spawn emitter at location. I'm saying the location is going to be the location of the barrel. And I'm doing the explosion thing. Everything else is the same. Okay. And then I'll put that back up in a second. So let's see if this works. See how it's centered on the center of the barrel?
Oh, that's cool.
Yeah, it is cool. But if we did this at the touch location, like that, then it's going to look a little bit different. You see that? You guys see that? The explosion's coming from the place where I touched the barrel. Right? Whereas if we did the origin of the barrel, then it's going to look a little bit different. Keep trying to sprint. We don't have to sprint yet. See the difference?
Oh my gosh.
So, to me, the center of the barrel makes more sense, but yeah, like I said, nobody's gonna
question you.
Yours does sound, but not the explosion. Okay, screenshot it, and I'll go back. Like I said, Katie, I'm gonna go back to it. I oftentimes like to test my code before my students copy it, because if I make a mistake, then they all copy the mistake, right? Like 2 fogs yesterday, right? Yeah, you can only have 1 fog in the world, right? And so if you, I told everybody to put an exponential height fog out of the world, but the template that we used had 1 in there already, so it didn't work. And so, like, my daughter this morning was having trouble with her fog, and it's because she had 2 fogs. You can only have 1 fog in the world. So
1 fog only.
Okay. Yeah, your thing's not wired up, Montoya. So remember, the white wire is the flow of control. So when there is an event, it first plays a sound. After the sound plays, then it spawns an emitter, and you have to have the things hooked up by the white wire. It's like in when you're coding, it's like having 1 line of code after the other. If you detach it, it won't play anything. Okay. Mm-hmm. Double fog. Yeah, and there's, I think there's a limit of like 2 directional lights in Unreal Engine as well. So you can have 1 fog and 2 directional lights, and that's it. So there, and they don't really document it, right? Like if you go to the, if you go to like the, I'll leave that up on the screen for a second. Actually, I screenshot on Discord. Like if you go to like exponential fog UE5. It doesn't say, warning, you can only have 1. I mean, it's got great examples and stuff like that. That's really cool. Secondary fog layer, pretty rad, honestly, if you ask me. Yeah, nowhere in there does it say, hey, if you put in a second one, it won't work. To me, it's like, document that. If it's an engine limitation, please document it. So, people might try and add another fog layer, like up in the sky or something. Like it's reasonable that somebody would try to do that. But okay, maybe it's not reasonable if you think about it a lot. But it's reasonable somebody would try. And so, to me, the documentation needs, like, if there's an engine like limitation, like, to me, it irks me when they don't document that stuff. Okay, so you guys good on the barrel? Okay, so spawn emitters, how you do a little particle effect. And later in the semester, we're probably going to learn how to do better particle effects than this, where you can make your own using a system called Niagara. And UE5 has some cool new stuff in it that I need to dig into. But for now, these are just canned explosions and fires and things like that. This is the old system. Yeah, legacy. Okay, and so what else do we need to do? We need to damage the player. Well, the player doesn't have health yet.
We also need to add a goal to the game.
Add a goal to the game, yeah. We don't really have a game yet. We need to delete the barrel. That's something,
Why?
right? Well, it blew up. Why would it still be there? It blew up.
Oh, yeah.
Yeah. So let's just add in the destroy or whatever. And it defaults to itself, so good.
What is it called?
Destroy actor, and it will default to itself. And there you go. So, looks better this way too, because I think before it was like hiding the smoke, like there's a little bit of smoke.
Yeah, it hit most of my barrel in smoke.
Yeah, and now if we drag out lots of these barrels, you can have a whole minefield of exploding barrels. Kind of fun. It's already a fun game. All right. So, what about a pushing force? Oh, you want to knock the player? Okay. Yeah. Okay. Player physics is kind of weird. I should mention that the way that all the rest of the world works is different from how the player works. And the reason for that is because the player is attached to something called a player controller. And you can think of that sort of metaphorically as like a game controller, right? Like you got, like an Xbox controller or something. And so rather than the boxes which get moved by other boxes, right? You go up and you push the box and it's pushed. You can think of the controller pushing the player around, right? And moving the player forward and backwards, left and right. And that interacts with the physics system in a really weird fashion. It's like the normal things that you do to like move things in Unreal Engine don't work with a player because the player controller, like if you make a change to like you see how there's like a location on the barrels here, like we could I can show you that real fast. So rather than destroying it, don't do this. I just want to set world location for self, and so I'm going to actually see here. I'm going to add world offset. So every time we touch the barrel, it moves up 1 centimeter. Okay. Didn't like it. Error. Target must have a connection. Okay, it doesn't like you. Alright, so let's try it. Scene component. Target is scene component. You. Okay. So don't do this. I'm just going to make a point. So.
Destroy itself.
Because it's not set as movable. See that? Hey, remember that bug I was telling you about? It's not set to be movable. It's set as stationary. Okay. So if we touch you and set it as movable, then we can do this. I must go. My people need me.
What if you stand on top of it? Like, Daddy, stand on top. Just jump. No, jump. Why isn't it moving? Daddy, you need
It's 1 centimeter at a time, girl. It's not.
What about that guy over there?
Oh, that one's not set as movable. Also, yeah. Okay, fair enough.
Yeah, that's what I mean.
You're movable. You're movable. Okay. Let's try this.
Yeah, what about that guy right there?
Slowly lifting off.
Slow. Make it like 2 meters.
2 meters.
Yeah.
Okay. Sweep.
Then you'll slowly get us into heaven.
Crash. Infinite loop detected.
What?
Infinite loop.
What do you mean infinite loop detected?
It triggered back and forth. Infinitely.
What's the matter with infinite loops? You'll have to do this very carefully, okay?
I don't know if you guys can see this, but the world's way down there. This is some Fallout New Vegas level physics right now. We're still going. We're still going.
We're still going up?
Yeah. We're in the clouds now.
Yeah,
We have ascended to heaven.
I don't know. Wait, let me see if I can walk around. No, I can't.
No, there's no air controller anymore.
Okay.
Okay. Right.
Wait, I actually can move around too.
Yeah, but there's no air control, so you can't move forwards and backwards. Okay, so that was amusing. And wow, we are.
Make it 3 meters.
How do I reset my position?
Press play.
Play? That's a good idea. There's some shortcut to jump back to the.
No, do it 5 meters now.
It's going to be even stronger. So.
I know. That's the whole point.
All right. Yes. 5 meters. Save, compile, run, and we're doing budget Kerbal Space Program now. All right. No.
No, it's because they don't have the plan. They don't have the code.
I think they're set to move. Whee! Oh, I had that at an angle. So we're oh, and we died. Okay.
You should have landed it straight on top of it.
Yeah. Okay. All right. Anyhow. So yeah, you can move things around and stuff like that, but that doesn't work for the player. To get to my point, the player does not move under normal circumstances, and so what you have to do is you have to. I mean, I guess we did move the player using the interaction of the barrel. But
wait, we should, yeah, just like that guy, we should put like a plane so that like if you hit it right, you'll go through this hole and then reach a new like an entire level.
Like a jump panel.
Yeah. That would be cool.
Okay, let's see if we can remember how to do this.
Yeah.
Can't take nerd. Get player.
Which one?
Okay, so that's the controller, and then let's add impulse. No, can't do that. Get movement. Maybe.
What if, like, we put, like, you launch into the air and then you launch into the air because there's another barrel and then you keep, like, launching into the air?
Movement component. Like I said, it's kind of involved, so if you don't want to pay attention, you don't have to. It's like set.
You should, it's really fun.
I'll have to look it up. I don't remember the name of the function, but yeah, it's not you can't just like do those things like with a barrel where you can just move it. It's like a thing. Okay, so we'll set that aside for now. If these things, by the way, aren't attached to anything, they just don't do anything. You just like go toss them in the code graveyard and just come back to them later. Okay. So what do we want to do? We want to damage the player. Okay. So and then we want to destroy the barrel. Okay. So Unreal Engine has a built-in damage system. Can you push some boxes? Yeah, you just turn physics on. Like there's like these guys over here. Right. So these things you just turn on physics, give them some mass, turn on gravity, and then they'll just behave like boxes. Like the explosion moves the boxes. Yeah, okay. So that would be radial impulse. Okay, I'll just do it. Whatever. I don't care. All right. So we're gonna do a.
Are we doing on the first or second barrel?
It's gonna affect all the barrels. All of them are gonna work the same way. Okay. And so I'm just gonna do this, and then you guys can like figure out if you want to copy it or not.
Multi-sphere trace for objects.
Yeah, I'm doing a multi-sphere trace for objects. So what I'm going to do is when the barrel explodes, I'm going to find all objects within 10 meters of us. Okay? And...
wait, does that include you?
Yeah, it'll include us. So I'm only going to...
Can you make it so that if another object touches it, then it explodes too?
Yeah, this will trigger on anything touching it. So if you push a box into it, it'll explode. And so we're going to do a multi-sphere trace. We're going to find all objects within 10 meters, and then we're going to add a radial impulse to them. We're kind of jumping ahead in this semester, but whatever. It's all good. It's a good question. So we're going to find everybody within 10 meters. Then we're going to say for everybody within 10 meters of us. Then we're going to add an impulse, add a radial impulse.
French.
Oh, no, this will work. Won't work. All right. Just hang out for a second, girl. Just hang out for a second. Don't worry about it. Get. Oh, that's a hit result. Actor. There. Add impulse to it. It's not a radial impulse. Hang on, girls. Hang on. I need to see if this works first. I know I'm going fast. Don't panic. I'm just going fast. It's fine. 10,000 strength of 100,000 newtons. Okay, let me see if this works. No, didn't compile. Why not? Error. Multi-sphere trace. I have to provide object types, and I didn't. So, multi-sphere trace by channel. All these things require explanations, and I'm not providing you explanations right now, so just hang on 1 second. Draw debug. 3 seconds. Compile, save, third-person map. Let's go ahead and put some boxes near these things. Okay, let's see if this works. It might not do anything. Oh, that worked. Pinball.
Huh?
It's pinball. Look at that. The box got knocked by the explosion off the wall, then it flew back into the barrel, and it knocked it again because it triggers on any hit, right? So.
Why don't we make a gun?
So if we just start tossing these things out,
Oh, you're gonna start making pinball?
you make a pinball game.
Oh, yeah.
Sure. Why not?
Just like a wall of barrels.
This will be fun. All right. Yeah.
No, how about like you start with like a box on top of a barrel? How about you start with a box on top of a barrel?
Got yeeted over the wall. Yeah, all right.
Nothing's thin air.
It just disintegrated. Okay, that's kind of fun. All right. So let me explain what I did. Now that I know that it works. I might have the impulse up a little bit too high. Let me drop it down by an order of magnitude. It's a little bit too strong, I think. There you go. But you notice, like, these numbers are, like, wild, you know. And a lot of times if you just guess the number, you don't get the right. There we go. Now, it feels about right. Maybe a little too weak now.
Excuse me, the barrel says.
And you can see these spheres. That's the 10-meter radius.
You should have it so it self-destructs and blows. That would be like more realistic.
Well, if we want to do pinball, then you know, then you could set up a whole course of this thing, and
just,
the boxes will.
Just like put like put a barrel here and a barrel there, and like in a circle, and just like and then just have like the box like spawn on top of one of them.
It'll just fly around. Yeah.
Or like make it just like a stack of them.
Yeah.
Just like a stack of them.
You can have a lot of fun with this. Let me explain what I did. Okay. Because we just leapt ahead a couple weeks, but it's all right. Good question. All right. So we started off here, event hit, right? We're all good with that. When we touch something, it plays an explosion, and it does the particle effect. So far, so good, right? You guys all good with this? This little part right here? This is how you get the location of the barrel. Okay. So I'm grabbing this guy here, static mesh component. You can drag that in, and then get locations on it like that. Everyone's fine with this part, right? You guys all did this part? You did this, right? You did this part, right? Okay. Now let me explain about how do you find things around you, okay? So, very, very, very commonly in video games, you need to know two things. One, who are the people around me? And two, what am I looking at? And there are, let me save this. This is pretty cool. It's pretty fun. So it's already a fun game. So, sphere trace is how you find things around you. Okay? And I'm saying find everything within 10 meters of me, and then I'm going to say for everything that is within 10 meters of me, I'm going to kick him using the physics engine. So the physics engine is going to apply 10,000 newtons of force or whatever, something like that. I don't know what the units are.
I don't get any of that.
Yeah, well, let me explain it. So, sphere trace finds things around you, and line trace finds things in a line. So, like if you're making a laser beam, then you do a line trace. There's something called line trace. And so if you want to find things in a line, use line trace, but we're doing an explosion. An explosion is a radius, right? And so if you want to damage everybody around you, like a grenade explodes, you use a sphere trace. And this is a multi-sphere trace because it can hit lots of things, right? So sphere trace is by normal hit, or they return the first thing. That's not very useful when you have a grenade. You want to damage everybody around you. So all the extra options for the for loop, I'll show that in a second. So multi-sphere trace by channel, there's three things you have to punch in. Starting location of the trace, ending location of the trace, and if you just want to do a simple sphere trace, they're the same, right? But you could take the sphere and sweep it through the world if you want, to make like a cylinder kind of looking thing. But normally the start and the end are the same. And so the starting and ending location of the sphere trace is the center of the barrel. So the center of the barrel is the start and the end of the radius search. And we're going to do a 10-meter radius. Does this part here make sense to you guys? So starting at the center of the barrel, ending at the center of the barrel, find everybody within 10 meters of us. Ada, does this make sense to you? 5th grade beat. So this is what it looks like. All right, watch. When you do a sphere trace, watch. There's going to be a giant green glowing sphere. You see these giant glowing green spheres?
Can we like get rid of those?
Well, yeah, it's just a debug draw. So this is showing you the radius of the sphere trace. If you want to get rid of the debug draw, you can turn this off right here. Draw debug type, none. Get rid of the debug drawing. I always draw them, at least to begin with, so I can see if the radius of the explosion is about what I'm like expecting. Okay. So this is going to return everybody in the world within 10 meters of us. Okay? That makes sense? Ada, do you understand what this is doing? If you want to find all objects within 10 meters of the barrel that just exploded, you do this.
So you sound like explosions?
Well, the explosion sound is over here, and the explosion emitter is here. This here is just finding, if you want to find all the objects in the world, because what the student asked for was when the barrel explodes, kick the boxes around, right? So I'm like, all right, I'll show you. We're jumping ahead a little bit, but I'll show you. So this is going to find all of the boxes nearby. Okay. So it's one of the most common things you do in video games. Give me a list of everybody near me. Okay. And then if you want to, yeah. And then you want to, let's see, line everything up. Yeah.
Dad, I don't know how to get the pop down for each loop.
Hang on, this is not. Everything needs to be lined up perfectly. The pop down for each loop. Yeah, I'm about to show you that. Okay, so this thing here is a list of every object within 10 meters of us. And then whenever you have something like that that's an array, or, you know, you see there's 9 little squares there. Yeah. That means you have to do a for each loop over it. And so that says, for each person near me, do something. What are we going to do? We're going to kick them using the physics engine.
No, my question is, how do you get the pop down for each loop?
This thing here?
Yeah,
all these options?
Yeah.
I split the pin. So it's for each loop, like this. So by default, it looks like that, right, Ada? Mm-hmm. And there's not like a whole lot of stuff here. Right here, where it says array element, I right-clicked on it, and I chose to split the struct pin.
Okay. Okay, there you go. I see it.
And then that gives you all the details there. Okay, that was the question a student asked as well. How do you get all those? How do you get all those things there? Anytime you have a hit pin, you split it like that.
Array element FISMAT.
And it's going to be array element hit component. Oops.
Array element. But when I did that, it got rid of my other thing. When I did that, it got rid of my other thing.
What other thing?
Add radial impulse.
Yeah, so we're going to add, so basically we're going to say for every object near us, we're going to use the physics engine to kick it. And the thing we're going to kick is the hit component. So that's the piece of the object that got touched by the sphere trace. The radius is a 10 meter radius for the radial kick. It's like an explosion kind of thing. The origin of the explosion is the center of the barrel. And we're doing a, say, a 50,000 Newton or whatever unit that is kick. Show one more time how to get the options. These things, you right-click on the pin and you choose split struct pin. So whenever you see something that says hit result structure, the normal thing you're supposed to do is pull that out, and the only thing that you can do with it is to break it open like that. And it's just like extra effort. So the pro gamer move to do here is anytime you see something that say hit result structure, right click and split struct pin. And then that turns the one dark blue pin into that whole list of things there. That's what you're pretty much always going to do, because there's nothing else you can do with a hit result other than split it. So rather than creating a whole nother node for doing the exact same thing, I just do it here. Okay. Does that work for you, Montoya? And then, yeah, if you want to see the explosions, draw debug for duration is, and then that'll display the sphere on the screen. So you can kind of see what you're working with. I always turn on draw debug. Anytime I do a trace, I turn on draw debug to make sure that, like, if I forget to set the location, it's going to be coming out of the dinosaur, right? so watch this. If I forget to set the location, which I do, the explosion comes out of the dinosaur over there, right? That's why I said leave the origin of the world someplace you can see, because you will screw up, and you will leave something set to the origin, and so being able to keep an eye on it to see that your explosions are coming out of there is a good idea.
Are you sure it's a lizard?
Or a lizard or something.
Dinosaur.
Okay, so let me screenshot this whole thing for you, and then you can peruse this at your leisure. Okay, so hopefully there's enough
Are we
data.
going to show each of our little projects?
Yeah, everybody shows their projects on Discord. So you'll need to
Hold it up to the camera.
yeah, something like that. Here you go. What time is it? 2:30. Okay. So I was gonna have the barrels like delete themselves, but I kind of like it right now, where they're kind of like a pinball effect. They'll kick those barrels, they kick the boxes.
What I want you to do is just like elongate them and just like make like this little cage. Move one of the squares into them.
Mhm.
So and then we'll like bounce around all over and over again.
Okay. Do you guys want to see that, a little pinball course or something?
Only one person's typing?
Only one person's typing.
Really? Okay.
Absolutely. Okay.
Okay, 3 people now.
3 people.
Yeah.
We got
Just
8 of those.
to make it 4.
Okay, let's make a little pinball course. Okay, so we'll delete you, and we are going to create a pinball course over here. So let's add a cube. Slide it down a little bit. Widen it out.
So we should make a hole.
A hole?
Yeah, like a hole, so like you're trying to get the pinball into it.
Oh, okay. All right. Up a little bit.
I mean, you did say pinball.
Sure. Okay. All right. Okay.
Sounds easier than done.
Okay. Let's scale it out. How big a pinball course? Is that too big?
Bigger.
Bigger.
Bigger. I mean, we're gonna be using life-size cannons and stuff, so.
Okay. How about that?
Yeah, just like slide it so it's actually aligned.
Getting there, girl. Chill. Okay. So this is going to be a pinball course, and naturally it's not snapped.
It's okay. Just like.
One tick to the right. There we go. Okay.
We need to put walls.
Okay. We'll put walls. So we'll throw out a cube. I'll do this. I'll do this. Actually, here. Cheat a little bit. So I'm going to Control W that, and then move. Control W.
It does. Control W doesn't work. You have to control.
Doesn't work? Okay.
Well, I guess it does, but you have to Control C and then Control V, just like a normal computer.
So I'm just going to do that so I don't have to.
You sure that's easier?
Think.
Are you sure?
Yes, girl. Okay. 9. Snap it to location, and then we'll do this, and then we'll do. So what I did was I held down Alt and Shift, and it duplicates it and drags along at the same time. So we'll rotate you negative 90 degrees.
Wait, no, you need to leave a little space.
Need to leave a space?
Yeah, so like that's like the space where like the pinball needs to come out.
I see. Okay.
Wait, so maybe like at the corners? Maybe like at the corners, just like shrink it a bit, so like you have to like
Something like that or something?
yeah. No,
Okay.
I think a little,
What do you think?
a little more on that side.
More shrunk?
Yeah, because remember you have to fit entire boxes into it.
I mean, that's
Oh,
pretty,
okay,
should be fine, I think. You know, we don't want to make it too easy on them, right?
Okay, fine.
Okay. And then what material should we throw on this?
We should use like just like a normal pinball ball.
I don't know, but what kind of material? Bricks?
No.
Is that not normal pinball?
No.
Yeah.
Okay. Right.
What do you think? Does that look good? No, it doesn't look good. Bush? It's transparent.
Let's just see.
No, that's terrible.
Ha.
Okay. How about like Chrome or something like that?
Google Chrome.
Not Google Chrome, actual Chrome. Yeah, it looks nice. Okay. I should have done that before duplicating it, but simple fix. Chrome.
Or you should just like select all of them.
I could. That's true. And then the goal zone will be gold.
Okay.
And then you.
Looks too flashy.
Chrome. It's a lot of money. It's a fancy.
Very fancy.
Yeah, and you can see the ray tracing here in effect. So.
Okay. Just like get to the pinball things.
Okay. All right. Enough goofing around. My daughter says. I only got half an hour left in class.
Enough goofing around for the goofing around part.
Okay. So we're gonna have all these barrels.
How do you make it snap down to the floor again?
End key.
What that is. Icing, really.
Icing.
What in the... It's spam.
It's gotta be spam. Okay.
They called you yesterday and you knew it was spam.
It's gonna take a lot of work to get these.
I know.
This pinball
That's what I'm
course.
having you doing.
Alright. Well,
I mean, you don't really have to put that much work. All you have to do is like drag the cylinders around. So.
okay, here's our.
Pinball?
Actually, rather than using that, maybe we'll use an actual
Yeah.
pinball, right?
Yeah.
Yeah. Okay. All right.
Yeah.
And we'll make the pinball. What color?
And you need to make just the explosion. Do the explosion material.
Yeah, it looks terrible.
Ooh. Yeah.
No, not skybox.
Why? Why not?
I'll make it a gold.
No.
No? Okay. Alright. And then we can add ramps and things like that. Like, oh yeah. Why don't we do that? Let's add a little ramp or something.
Yeah.
Okay.
That is not a little ramp, Daddy. That is not little.
This will be like the start thing.
Oh yeah, that's actually a good idea.
And we need to make it movable, of course. We need to turn on simulate physics, of course. And then let's hit play. And just, there we go.
Let it do its
It
thing.
rolls down, and it hits that, and it gets kicked that way. Sweet.
Wait, so if it gets kicked that way, we should put like something right there. We should put like two of them like right here.
Yeah?
Yeah. You're making it to Daddy, you're cheating.
It's like Rocket League.
You're cheating. You're cheating.
What's wrong?
Why are you cheating? And
I win. I just won the game.
You cheated.
Okay. All right. So students, what do you think? My daughter's giving ideas here, but you need to as well. You can have lots of those, girl. If you alt drag, you can duplicate them out. So what should we do? We're making a little pinball game here. Yeah, we got 22 minutes left in class. Let's do this.
We definitely need some at the...
I think we need a lot more of those pinball things.
I know, but I'm still using what we have.
We should probably put walls in as blockers and...
Then, I mean, I guess it actually is pretty easy. All you have to do is like make a mazy thing. And we also need to up the power.
Your barrels aren't being activated by any collision but the player. Interesting. I don't know how to make holes in the ground, but there should be a way to fall. Okay. Here, let me show that. So, you can't modify a static mesh. This thing here is a static mesh. A static mesh is static. It can't be changed. What is a mesh? A collection of triangles.
Why can't it be?
It's static. So if you want to
Stationary
see
mesh.
the triangles that are involved in the world, what I did is I clicked up here and went into wireframe mode. You can see that the surface that we're playing on here is a 1, 2, 3, 4, 5, 6, 7, 8 triangles. That's it, more or less. Okay. A little bit more because it's technically a cube, but yeah, it's basically 8 triangles. All right. And everything in 3D is made out of triangles. You can see the skybox is made out of triangles. The ramps are made out of triangles. Everything's triangles. The cubes here. Yeah, you can see.
Not really.
Okay. Cylinders are obviously quite a lot because you need a lot of triangles to make them look rounded. So, you can't cut a hole in the floor. That said, there is something over here called geometry. And under geometry, you actually can do what's called constructive solid geometry. And if I delete you, and I put in a different box here, this is a geometry thing. I'm going to need to redo this like it was before. Take it up.
Good enough.
Yeah, technically you can't see the stuff out there.
Good enough.
Oh, well, the walls don't go all the way out.
Good enough.
Problem.
It's good. It's good enough.
There you go. Take it back one, maybe? There we go. Okay, so if you have geometry, then you can cut a hole in it. Okay? And so, materials, starter content, materials, little chrome out here. Yep. All right, so here is our floor, okay, and the ramp. Maybe we'll make it glass. That's kind of cool looking, right?
I can't even see it.
It's glass, girl. You can't. The shaders have to come out. Okay, now you wanted to cut a hole in it. Okay, so let's make a cylinder, right? Wherever we want the hole to be. Where do you think the hole should be, girl? Here?
In the center?
In the very center?
No, just like and like
Okay.
the like right there or something. Listen to your students. Hello? No? Okay.
Like cubes aren't being moved by the player, but they're set to be movable. You need to make sure physics is on them. Okay, so if you want to cut a hole in the world, you need to get a cylinder that kind of punches through the floor all the way.
In
Oops, that's the wrong direction.
in 3D printing, you put a shape inside another shape and then select it as whole.
Exactly. And so, this guy here is going to subtract out. Where are you? Where is the subtract button? Oh, the floor is set to glass now too. Yeah.
I mean, I like the floor as glass. No, keep the floor as glass.
Okay, you need to be set to be subtractive. If I can find where you are. Subtractive. There we go. Okay. So you got the ball going through like that. It's kicked over there.
I'm trying to say that we need. We really. Really?
Yeah.
Okay.
So what you do, hang on, let me explain the process, okay? Because we don't have a lot of time left. So you make rather than using a static mesh, using the normal shapes over here, you go to geometry, and these things can add and subtract to each other. So you can add geometry together, and you can subtract geometry from other geometry, and it carves it up. So if you want to put a spherical hole in the floor here, you can drag out a sphere, kind of move it into place.
A sphere.
Everything's approximated with triangles. And then you select brush type subtractive, and then then there will be a circular hole for the balls to fall into. Okay?
That's not good because it's wait. Oh, that's cool.
Mm-hmm. Yep.
But if
The
like,
cylinder.
can you move the hole?
Yeah, of course. It doesn't actually go anywhere, right?
Yeah.
So you can actually do that, and then you can change the tessellation amounts, so you can make a much finer sphere. Right?
No.
You like the rougher one?
Yeah.
And so basically, here we go. Step 1, make a additive plane of whatever size you want. Step 2, whatever shape you want to cut out of it, you drag that over, overlap the geometry, and then you select subtractive rather than additive. And it will subtract that geometry out of the other geometry in the area. And by using additive and subtractive geometry, you can build, not super detailed things, but like enough. It doesn't replace Blender and things like that, but for something like this where you just want to have a surface with like holes cut in it, then you can do that. So go ahead and, I see, Tim. So my daughter will go ahead and play with that, and then I will help the people not having problems with the explosions. Okay, so your explosions only happen if the player touches it, okay? Your cubes aren't being moved by the player. Just have to be movable. Physics on. It's working now. And some view. How do I add the trace channel to the multi-sphere trace? You actually search for multi-sphere trace by channel. Is what you search for. And that's gonna fall if it's what is the barrel set to? Actually, is the barrel set to stationary? Are your barrels set to stationary? It's actually a question for you, Tim Crom. Ah, that's cool. It'll kick the thing back up. Your barrels are movable. That's probably why. Try setting the barrels to stationary. And if they're set to movable, then you need to tick a box called simulation generates hit events. Because when they're movable, the physics engine's going to be moving them every frame. And there's a tick box. Let me show you where it is. Ada, give me a second. Right. Box here. Physics, you have to turn physics on if you want a movable, gravity's on, have mass, and then there is wake should be on for sure. Collision, simulation generates hit events should be ticked like that. Okay. And collision presets, probably changing it to physics actor will also be a good idea as well. So set that. Okay. I'll screenshot that for you if you want your barrels movable. Here. Yeah, if you make it stationary, it'll work. But if they're movable, then you have to generate hit events. So, okay. Let's take a look at your world, girl. So I got this coming in here. Kicks it. It's gonna go into the hole. Ah, it missed. Oh.
We need to make it more powerful, like I said.
That's funny. It actually,
Dude.
yeah, it does need to be a little more powerful.
Just make the individual one into more powerful.
100,000.
That's okay.
Save all. And play.
I hit off at an angle this time.
Ooh.
So, oh.
Ah.
Wait, so you need to make more than just a few. You need to make more.
Yep.
You need.
Still want to activate for the cubes. Do you have your barrels as stationary or movable?
Yeah. I love you. Oh, okay, I figured that out. Wait, we should make a variable so every time it falls out, then like it adds 1 to the score.
Yeah, we can do that.
We could do that later.
Okay.
This guy's still going. I'm just gonna help him a little. No.
So homework for today, let's say, is building pinball. Okay.
I have to build a pinball.
You have to build this. Okay. And we got 10 minutes left. Let me show you how to do score. Okay. So let's do a little thing here.
How about we make a basket so you can count how many?
So you can catch it.
Yeah, it'll be easier. Just like make a little basket.
So maybe do some of these things. Just need to have enough that it's kind of interesting, right?
We need to have more. That's what. That's too many in a single area.
Yeah. Well, that's good.
Look at all my little pinball. Oh yeah, we have to get rid of that one. 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 Yeah. Okay, pause the game and like.
Okay. Anyway,
delete
we
it.
don't have time. We can mess with this later. So let's do a scoreboard. So if we wanted something so that like when the balls come out this way, you get a point. How do we do that? Screenshot my code again. Yeah, you should be able to scroll up and find it. I haven't changed it at all. If you scroll up a little bit in Discord, I've got all this screenshotted here. So event box, yeah, event box. Yes, I know what you're saying. Trigger box, right? So we want it so that when the it's not quite lined up.
It's okay. It doesn't have to be perfect as long as you can see it as it's
That's
perfect.
the kind of thing that bugs me. Okay, so yeah, we need to add a trigger area over here, right? And so Ada wants some sort of like basket. We could do that by doing a cone and then carving a smaller cone out of the bigger cone.
No, that's just way too hard.
It's just way too hard, right? Nobody has time for that, so I'll do it anyway. I don't care.
Oh my god.
Yoink. Down there.
We need to make it bigger. Wider.
Okay. Copy. Paste. Shrink. And subtractive. Okay.
Addictive.
Alright, you guys see that? You probably need a material on it. So let's do materials.
Glass. What do you guys think?
I'll just do basic wall. I should have done
Oh,
this.
he says gold.
Gold?
He says gold.
Alright.
Why are you guys so addictive to gold?
I like gold.
Wait, how about we make every single panel one of
Okay.
It's shiny. Okay, you can stop listing reasons.
Okay, so what I did is I took a cone, I flipped it over, I copy pasted it, shrunk the second cone, And now we have a little cup. Oh, it carved into the actual world a little bit, but there you go. There's a little basket, right? So CSG, constructive solid geometry, fun stuff.
Wait, we need to like add a ramp so like kind of like slowly like.
Well, we can worry about that later. Okay, we want a scoreboard. So as I think somebody said, we need one of the Tims. I think your balls don't explode. That's probably a good thing. So we want a trigger box right here.
No, make it bigger, bigger,
Yep.
bigger.
Scale it up. Scale it wide. Scale it tall.
Scale it even wider.
Okay. And now we want whenever something
Add one to the variable.
whenever something enters the
Box.
zone, we need to add 1 to the variable. That's what my daughter says. Do you guys concur? Is that a good plan? Anytime something enters the zone, we add 1 to the.
But what if it like bounces back out?
Probably won't. But yeah. You concur? Good? Alright, let's do this. So we got our zone set up here. Bill. Where are you? There you are. There's no blue button anymore. This is going to be called score zone thing. Okay, whatever. Score zone. And we hit save. And here's the picture of us. Event graph. Don't care about you. Don't care about you. But when begin overlap is true, then we are going to. Oh, we need a variable. What should the name of our variable be, Ada? Here, I'll let you do it.
Scoreboard.
Okay, make a variable of type integer. Click on the plus. Name the variable. Yeah, type it. Type is going to be integer.
Integer.
And then the name is going to be
scoreboard.
score. Just score is good, I think, maybe. And then you have to compile it and save it for the variable to appear. It's one of the downsides. Okay, the default score is 0. Is that a good starting score?
Yeah.
Yeah, I think so too. So when somebody begins overlapping with us, here, I want you to do it, girl. I want you to get the score and then add 1 to the score.
Score if it is at.
Type plus plus to increment the score, or increment integer, or add. One of those will work. There you go. Increment int. That's what you want. And then drag score onto the green pin right here. Onto the left pin.
Oh, come on.
Delete it. Okay. Drag score onto the left pin. And there you go. And that will take the score, add 1 to it every time something begins overlapping it. And then we'll just print to the screen the new score, right? I want to line these up, sorry. Okay, so now, sorry, yeah, I just had to do that. So now, drag out and have it print the score. It's a simple way. In the future, we can show how to like do a scoreboard in the word
I'm
itself.
saving that.
Good, save, compile. Drag out the white pin on the right-hand side. No. Right here. Drag out. Oh, nope, you made our face too big. Okay, nope, we're done. Oh, sorry. Okay, drag out the white pin right there. We got 3 minutes left, girl. Let's do this. Drag it out. Print. Print string. And then the score we're going to print is...
Yay.
Nope, actually, what we're going to do is we're going to take this is the new score here. We're going to print that by just dragging it out like that. You see that? And then that is going to print the current score.
Why do they need that?
Because this is a string, this is an integer, this converts from string integer to string.
Can't they just go across? Why do they have to put that flashy little piece?
Anytime there's a different type, it has to do type conversion.
I know, but why does it have to? Or we seriously need to get rid of that ball. It's just always gonna like.
There we go. No.
Where's the score?
It didn't. No score. Oh, when we enter it, it gives a score.
Yeah.
So these things are not generating overlap events. So let's see if we can figure out why. This ball here. Oh, you made a ton of them too.
I know.
We're gonna have to
Spread them out.
One too many. We have to figure out why it won't generate an overlap. Generate overlap events right here. Any advice for crates on interact with my barrel? That's kind of what I'm getting at here, Katie. Is that under the collision settings, there's options for all those different collision things. And so generate overlap events should be turned on. Generate hit events should be turned on. And so whatever object is not colliding, and you have to do this for both the objects, for the barrel and for the box, make sure that they are generating hit events. And then it should work. Let's see here, save all, play.
There's one single ball.
There's one ball. Don't go into the hole, don't go into the hole, don't go into the hole. No, 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 no. Maybe we should have copy and pasted it. Oh, no, 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 no.
Don't worry, there's a barrel.
No. Oh,
There's
shoot.
a barrel. I told you, there's a barrel in there.
Ah, I died. See if we can do it better this way. There we go. It's going the right direction. Okay. No. Intercept. There we go. Ah, it counted this time. You see that? 1 point. Now the trouble is...
we copy and paste a bunch of.
Well, the trouble is we count for the score too. Oh, look at that. Exploit, huh? So I'm going to show one more thing before we go away. Today it is 3 o'clock already, but we're going to go to the score zone thing.
I'm going to start working on my own already.
Okay. So Cromwell did that work when you... they're interacting, but it won. Okay. All right, so let me show you one more thing. Before we add to the score, we need to check to see if the type of the thing that hit us is a ball or not. Now, we don't actually have a blueprint for our ball, so we're going to have to kind of cheat it a little bit. And what we're going to do is say if it's not the player, give a point. Okay. So how do you check to see if the person who overlapped us is a player or not? Well, there's a node called cast2 player character. What is the type? This is third person character. Okay. Character. Okay. And so basically, what you can do is you can try converting whatever it is that touches us to be the character type, and if it fails, we add 1 to the score. So I'll screenshot this for you as well. This is actually a very common trick to do. Let me just make sure it works right. I always check to make sure it works before I have you copy me. And the ball's going in there. Okay, so you see when I walk over here now, it doesn't trigger anymore. But I need to see if it works on the ball. This game's a little too hard for me right now. All right. No. One more time. All right, here we go. I need to add sprinting to this game. Intercept. Okay, there we go. And we got a point. Sweet. Okay, it does work. So the trick is this: if you don't want the player to line these things up, if you don't want the player to trigger the score, what you do is you take the person who touches the zone. You try converting it to the third-person character. If it succeeds, it means it's the person, and we do nothing. But if it's anyone else, then we add 1 to the score, and we print the score. Okay? So I'll screenshot this for you, and we'll say that your homework for today is building a exciting pinball game. All right? And okay. Here. You guys have any questions before I switch over into IS50B mode? You might have noticed that it can be very frustrating getting overlaps and hits to work, because if one checkbox somewhere isn't checked, it just doesn't work. Okay. So, they're interacting, but it won't bounce. Crate's not interacting with your barrel. So like it's not generating an event hit or something like that. Make sure everything is stationary, not make sure the barrels are stationary, not movable. And you might have to set that for all of the barrels. You might have changed it on one, but not all of them. And on the boxes, make sure the boxes, whatever it is that's moving around, like that guy, make sure that they have generate overlap events turned on, generate hit events turned on. I'm using a preset for physics actor, and generate overlap. Well, that doesn't matter, I don't think. But I'm not doing any level streaming right now. But let me just save this part here. And this is the settings on the movable ball. Okay. Oh, your radial impulse is way too weak, Katie. 20 impulse is, you're not going to notice it. You need to, let me pull that back up here. And I'll screenshot the right-hand side here for you. I'm using 100,000 units of force. Yeah. So, yeah, your radius is 10 centimeters, so it won't even probably touch the thing at all. So you need to make your radius much bigger, and you need to make the strength much, much bigger to kick it. So even though I'm using 100,000, which seems like a really large number, it's still just kind of kicking it at about the speed you'd expect. So the units are really weird when it comes to the physics engine. Yeah. Okay. All right. Cool. Thank you, IS50A people. Have fun making a physics game, and mine is on like a flat, plane like this, but you can add, inclines and ramps and blocking walls and stuff like that too. So it should be a fun little project, and just add a little score zone that just prints the score. Like I said, in the future I can show you how to show the score in the world itself, but like I said, don't worry about it. Print string is what I usually start with, just to make sure it works. When do you upload your lectures? After IS50B is over, so it'll be up at around probably 6, something like that. All right, thank you 58 people. I will see you tomorrow.